650 and 61400-25. I disseminated IEC 650 and related standards to thousands of attendees from more than 1,000 companies and 90 countries in more than 250 seminars and published more than 100 papers. You see me in action in the midst of 650 supported power systems. Short outline, I'm talking about real world and standards. I started my work with as an apprenticeship in 1969 as electromechanics at Siemens, studied later on IT and ET from 77 to 82, returned to Siemens back. But I was frustrated with proprietary communication solutions, got engaged in working for IEC standardization. Impact, objectives, goals, and customers' benefits for 650. It's mainly the SCL as one of the core parts of IEC 650 series. It replaces Excel tables for signals, so we get models, replaces hundreds of proprietary and standard protocols, and replaces tons of copper with fiber optic cable. I will talk about a little bit the all-electric world. The KIT, that's the university here in Karlsruhe, my home city in Germany. The electric power systems are the biggest man-made systems. Almost 150 years, we're relying on it. Electricity is needed for our living 24/7. So what do we need to study at the university to understand everything related to electric power systems? It's quite important. Where to study 650? That's not easy. So education regarding IEC 650, that's really very, very crucial. Understanding the all-electric world takes decades. We know it's really a big issue. The pace of the development is extremely high. Comprehensive training of fundamentals, protection and automation and cybersecurity are of high priority. We talk about IEC as an organization that has published more than 10,000 standards. So it's a huge organization, and I have worked in the IEC many years. Now as a retired person, I cannot travel that much anymore. Okay, now let's look at what is IEC doing. If they want to help to build systems and infrastructures that are interoperable. So interoperability, you know, that's a big issue also with 650. So in 650, we have 46 parts published. So we have one general protocol. It's in part 8.1. We have two special protocols for goose and sample values, as you may know. So that's really helping to provide interoperability in the industry. So when we look at the international field bus community, the IEC 61151, we have 80 parts, and we have more than 20 protocols. Okay, this is questionable if that's interoperable. It's interoperable within one solution, but we have 20. 650 series, we have the 46 parts, as I mentioned. It's a total of 7,361 pages. Don't worry, do not read them all. Really, don't do that. What is important, before you buy standards and read them, get first fundamental education from experienced engineers to understand what you should read if you want to read a standard document. After such a training session, you will understand what may be of interest for you and your company. There will be no edition 3 of the whole series of 650. You may be surprised about this statement, but that's true. It's really confusing. The core parts, part 6, 7X, 8.1 will be published soon as edition 3. I guess maybe next year or the year after. But there will be other documents, new documents that will be named and called edition 1 of that document. So let's look a little bit back in 1970 when I worked for Siemens as a young man. So this is a drawing of a system, so to speak. So we have operate command, we have switch control. In terms of 6150, it's a switch controller, CSWI. We have conducting equipment, we have switches, we have positions, we have connectivity nodes, we have currents and voltages we can measure here on these points. So it means this is, of course, primary and secondary wiring together. But in general, it's electrical system. So with 650, now 55 years later, we can see, okay, this is what we have today, drawing described in an SCL file, a system configuration language file, XML-based wiring diagram. That's configuration, okay? So that's, so to speak, not so new. So another question is, what is a long-witty 650 standard? We have, over time, we have the three-phase currents and voltages of the AC system. We have the physics, and then this will not change. And that's a good news that it will not change. We have the generator speed, we have oil pressure of a transformer. A lot of these signals, information we have that do not change in 100 and more years, because that's a good base for the standardization. So we have information models of the real world objects. We have abstract communication services and configuration language, which will live for a long, long time. So there will be no change so far. We have life cycle of systems that are shorter. We have methods, we have service mappings, languages, tools, interfaces, and we have the innovation of hardware and software, of course. So we cannot rely on hardware and software and standardize these. We have to do something that standardizes, that has a chance to live beyond of a special hardware version or software version. Everything has a name. In 6150, we have primary systems, we have transformers, big ones, small ones, we have air-insulated substations, we have gas-insulated substations, we have secondary systems, protection, control, metering, monitoring. And now with 650, what we do is we are standardizing so-called logical nodes, so PTOF, protection, time over frequency protection. We have data here, we have start, operate, start value, and so on. So this is, so to speak, a description of the used protection function. And we have, for the circuit breaker, we have other data in here. We have the position and so on. We can switch this. We have the MMXU, the measurements. We have the frequency, phase voltage, and so on. This is all standardized. We have the so-called S-temp, the supervision for temperature. We have an alarm. We have the rate change alarm, trip, and so on. So this is giving you a clue what 650 does regarding the signals and the models. So we have in IEC, we have the IEV, electrotechnical vocabulary. We have the voltage or tension or Spannung or whatever. Because it's per language, it's different. So we have no standard language for that. So we have in Finland, we have Janita, I do not know how it's pronounced. Okay, this is one country, but in 650, we want to do something for the whole, for the globe, for everybody. So we are standardizing, defining one standard container or a model for all the communication use cases. So we have the logical node MMXU. So the MMXU is worldwide in use. Phase voltage, we have phase A, we have instantaneous complex values, magnitude and integer, we have a quality timestamp, we have the units, everything is together in one model. So we have all this information together, and all these names you see here, These are all standardized names. So question is, do not use AC power. Okay, why are you using AC power every second in your life? You should not use it because it's so complex and it's dangerous. Hey, what I'm saying? Yeah, it's dangerous. Of course, it's complex. But worldwide, we are using it for almost 150 years, every second safely. So complexity is managed by people like you, especially the protection people that learned to understand the physics behind and grew up with the technology. So you have learned a lot of experience. The solutions are implemented, tested, used, improved, tested again and again to make sure that the physics will not harm people and equipment. So 650 requires special tests and test equipment. So we have equipment from many different vendors, from Mega, IED Scout, from Omicron. We have the different test tools. So these are all important to test the different aspects of the electric power system. So again, thank you to Omicron to organize this event, to show that it's so important to have that we have these companies like Omicron, Mega, and other companies that are very serious about the testing of electrical systems. So we have electricity everywhere at any time. We need electric power for our living. I have nursed my beloved wife, Ingrid, from January 2017 until October 2022, when she passed away. She suffered ALS, needed a non-invasive breathing ventilator 24/7 because she could not breathe with her own muscles. So we needed AC for breathing, for the lifter, for nursing bed and everything. We had a lot of electric systems, and so I installed an islanding PV system in my backyard with some batteries. So in case the electric power system has a problem, we can at least operate these devices. There's no need for 650, of course. The electric power is more than substations and IEC 650. It's mainly a physical system with wires, with generators, with voltages and currents and so on. So we have the impact of 650. What have you heard about 650? Maybe you may have heard it's too complex. 650 is not just another protocol. But quite often you see 650 is a protocol, but that's not the full story. It's very complex. Now it's comprehensive, not so complex, but it's very comprehensive. And that makes the story not so easy. Do you think physics, electrical three-phase AC systems, power transmission and distribution and generation are complex? Yes, they are complex. The three-phase AC systems have been developed in some 150 years, so we cannot change it overnight. And I have learned yesterday when I followed the presentations. So inverter-based resource renewables seems to be a new challenge. I have learned yesterday. I was not really aware of that, but this is very, very important. It's a challenge. So please, everybody listening today, take this very serious and get involved in solving that problem or these problems. To understand and make them available, you must study them in detail, of course. That takes efforts and time before you practice, like an open heart surgery. Be aware, physics will respond mercilessly. And I guess you know it as a protection engineer, you know that. So objectives, goals, scope was first in some stations for electric power systems. So scope has been expanded for applications outside the substation. It's not just another bus system as mentioned or a field bus. So it extends the way automation devices work together. So the title 650 says communication networks and systems for power utility automation. I would like to get rid of power utility. I would like to say for automation. It's can be used for any other system where you have electricity, where you have a motor, or we have a relay where you have temperature monitoring or pressure monitoring, you can use 650 as well. The focus is on what we communicate. We define the semantic. We have the content in an XML file. If you're familiar with XML, you can see here, so that's a measured value, temperature, it's TMP, it's the units, it's in centigrade unit. For many Excel tables, the single SCL documents, I think that is one big issue here. How to communicate is defined as well. We select and refer to communication protocols. Some special protocols are defined. On the right-hand side, you see this is the value, temperature value or voltage or whatever. We can have limits, limit 55 or 70, 120. And that may have different semantic. So maybe between 0 and 55, it's good. And maintenance required, maintenance dedicated, demanded, and so on. So this is part of 650 models as well. So we have the single configuration language for the power system, devices, data communication. With tools like OpenSCD, likely this. But I want to tell my story about tools, okay? 650 is a tool. The SCL editor is a tool. I'm usually saying, okay, even a fool with a tool is a fool. And a fool with a tool can fool up a project much faster than a fool without a tool. So tools are good, but you have to learn them, how to use them, what they do. And 650 is, of course, defined for multi-vendor systems. Defines communication interoperability at a high degree. So 650 could raise a red flag in case of a problem. So we have a damaged transformer. We have a problem here. And the question is, where do we get that information? When do we get it immediately, or is it in an Excel sheet or so? So we have the transformer, we have the STEM. So STEM, as I mentioned, we can have different settings. We can the settings for the deadband value range limit, or we can do polling, we can do a report on change, update, and periodic. So we have a lot of possibilities built in 650 to configure the communication for critical conditions if you want to use it. One standard for many phases in the life cycle of a device or a system, we can reuse the standard classes, substations, base. We can have a complete bay, let's say 20 different bay types. We can define them and reuse them for other substations. We have the metadata, a lot of data about the data. So we have SI units and so on. So seamless naming convention for the field level, that's quite important. As I mentioned, it's useful, can be used worldwide, not depending on language. We are using advanced communication technologies, easy integration into web technology, that's possible as well. It's scalable, flexible, expandable, and most important, it's available. It can be used. So we have another issue, top-down or model-driven engineering is one of the next big challenges. So we have here a diagram we show here. That's from Enel, the green power. For the hydropower, people are working on that to have a machine-readable profile of an application so that it ends in a vendor-specific PLC programming language. So I use this to compare this with my opening statements about the relay drawing here. Okay, that means it's a topology, and then we have a function. You cannot read it in German, of course. That's what I have written some 55 years ago, describing in plain text what the relay diagram, what it's doing. So this is what they want to do as well, to have a full description and the program, maybe in PLC language program, contained in SCL, so that we have everything together in one place. Then the big
Engineer
question
Carl,
is about
to interrupt, you have 2 minutes to go.
5 minutes?
2
Okay.
minutes.
Yeah, we have the big question is what to study. When you're a young person, you do not know what to do. The computer science, you can go to the university for ET, IT. But when you look at 650, you don't find it in these, at least here, not at the KIT. So we need to build a bridge 650 between the two worlds. So I have checked a little bit what's going on, what they offer here. They have different modules. They have hundreds of modules. And when you look into 618 here, you see, they're talking about physical, technical basics, routing, OSI, and so on, but not 650. But finally, we found it. R&D at the Institute for Automation Applied Informatics here at the KIT, they do cybersecurity in substations. They have built substations in a lab, a big lab, and they do a lot of testing here. So the 6150 standard series is not yet main topic in computer science nor electrical engineering, information technology. So the education and training for 6150 is available by various market participants, vendors, consultants, individual gray-haired experts like me. Okay, so I found another document that is quite new from the EU. I'm not reading this here. The question is, what is required in the future? So it requires a lot of education and training. And they even refer to 650. Professionals must be familiar with communication protocols and standards like 650 and so on. So that's quite important. So urgent need for workforce upskilling and reskilling. That's what you need to do. And we have 1,000 or more people today to listen. Take this very important. And of course, we have 650 over the time. We have started with the content of the protocols, schools, and sample values, and so on. But then we started to understand more the protection automation, started at brownfield engineering and so on. So next, we started to look at the securing systems, cyber physical security for 650. And now we have everything is now wrapped with the cyber physical security for 650. And of course, help is on the way to understand what that means. 650 basics, we have the applications, we have cyber physical, and you cannot separate one from the other. So everything is about people. The future of power system is about people. Standards, devices, components are made by people. Tools are developed and used by people. Cyber physical secured systems are designed, engineered, made, and configured, operated, and maintained by people. It's always people. Focus on the most critical asset, you and your people. And I want to say this, also to the management, if you are a manager, be very serious about that. Let people learn and understand what power systems and 650 are all about. So first comes power systems. Plan your and your people's education as a critical step. Start now. Start now with baby steps, of course, but how long will it take? It may take some time before you get an adult in these technologies, but then you're able to climb here and to make it a big success. So the questions we can have immediately, so just the last slide here. The time has come. Learn how electric power systems work. That is in bold, big, large letters here. And then, of course, and how 650 helps managing complex power systems. Thank you very much. And now it's open for questions.
Thank you, Engineer Carl, for sharing your expertise with us. Apologies, but we do have a lot of questions for you, but due to the time, we will send them to you via email for you to answer them offline, and we will surely pass these answers to the participants. Thank you very much. And we now move to our first technical session of the day, Data and Configuration Management Impact, presented by Engineer Rooney from National Transmission Company of South Africa. Engineer Rooney, the virtual stage is yours.
Thank you. Good day. From the keynote, we've had that 61850 has been a standard for interoperability, and it's being used, and it is going to assist in the operation of the power system coming in future. But now a challenge comes in: how do we manage the data and configurations within the protection, automation, and control systems? So that's the topic I'll cover, the challenges and some of the mitigations or proposals that we can use to prepare for the digitalization of the power system. My name is Ronnie Lihutso. I'm from the National Transmission Company of South Africa. I'm a chief technologist in substation automation integration. On the left here, you can see a picture of me here with some relays here in the 1960s. So if I can just take you through a journey of the relays and how configurations come into play. In the 1960s or early in the years here, we had electromechanical relays. So these electromechanical relays did not have any file configuration or anything that existed on any type of file. The configuration only existed on the device itself. We did not need any computer or laptop to configure these devices. In the instance there of my picture, we had to replace one that had faulted due to a breaker explosions, and to do that a change to a new device and transfer the configuration was swift, quick. We did not need any configuration, any laptop, any computer to do that. And then the relays then moved now from relays to digital IEDs. So digital IEDs go through different generations. In the first generations, you had digital IEDs, but with no communications or that. And then you've got maybe a second generation where you had a digital IED that consisted of a configuration, and that configuration now had another component to it, which was communication. That communication could be serial based or any other type. Then we moved to another type of generation, which now included IEC 61850, which added more configuration component to it. So now you've got the configuration of the logics of the device itself, you've got the communication configuration, and now we're adding a 61850 configuration. That's the current status of digital devices within the substations, currently where we are in terms of devices and configurations. And what is currently in the making or in the future is about virtualized IEDs or functions. So this is a computer that will run independent. The software will run independent of the hardware from any OEM. And now these types of substation automation now brings in another layer of configuration. The configuration or configuring these devices now includes configuring the computer itself with the host device configuration. That can be your operating system. On top of the operating system, now you add in your hypervisor configuration. On the hypervisor, you add your virtualization or your container configuration. And then lastly, you still need to do your IED configuration. So from the electromechanical relay to here where we are and where we are going now, the configurations have now increased. Now, for an efficient power system to use the 61850, to have interoperability as we expect stipulated by the 61850 standard, we need to manage the configurations in a good way. But now, what is a configuration? In general terms, a configuration is the arrangement of parts, settings and relationships that determine how something is set up and operates. It is essentially the blueprint plus the settings that define what components exist. So in the electromechanical relay, it would be the coil, if it's a 30-volt coil, or a 110, the AC coil that will be generated 5 amps or 1 amp input, the contacts, and then the settings would be the plug setting pin that will pull out or pull in on the electromechanical relay. When we get to digital relays, it goes further now, the software that you're going to use to configure and those things. And then it also explains that a configuration is how are they connected or arranged. And then lastly, what parameters or options are chosen to work, to make them work in a particular way. Using the electromechanical relay, for instance, if I want that relay to trip at a certain time, like 2 seconds, I would need to set the time multiplier and the pickup at a certain point so that it can work in a particular way. So where and what do these configurations do in a PEC system? So here is an overview of a PEC system. So here at the bottom, we have the power system. I think this is the core, this is the heart of what we're doing. As Engineer Carl has explained, we are generating, transmitting, or distributing power from substations. And from here, we have the process level here at the bottom. At the process level, we then collect the information into the station level. In the station level, the information will then be shared amongst the devices, or either will be shared now to the control center to report that an incident has happened in the substation. This is done using IEC 61850, as it is the standard that we should be using for interoperability and all other benefits that it has. If I zoom in here in a particular bay, I'll use here a transformer as an example. If we look at a transformer bay, we have here at number 1 a measurements IED. So the measurements IED will collect information from your CTs or VTs. And for it to be able to collect this information in the way that you would want, you will need a configuration for the measurement IED. We move then to the breaker IED. So the breaker IED will collect information either from your conducting equipment, can be your breakers, your isolators, your earth switches, or any of those devices. And for it to do that in the correct manner as you would want, it will need a configuration. And then thirdly, with the transformer IED as well, if we want to collect information from your winding temperature or your pull-holes, from your tap changer, or any of the components that are sitting on your transformer, we need a configuration within that device. And then all those information from 1, 2, 3 will then be sent via the 61850 Goose protocol to the protection IED. That will be the IED that's performing the protection, doing the algorithms for the diff trips, your restricted earth fault, and all those things. And for that, we need a configuration as well. Now, using 61850, it's not just about the devices talking to each other or hardwired. 61850 is based on 802.3, the Ethernet protocol. So for the devices to be able to communicate, we need an Ethernet switch there at number 5. For that Ethernet switch to enable communication between these IEDs to communicate, we would need a configuration for the Ethernet switch. Now it brings in another component. The protection principles of selectivity, sensitivity, and what are not just based now on the protection device as well. It will also be affected by the Ethernet switch. And then this information now must be then reported maybe to a SCADA system, so that a control center sitting remotely can be aware of an incident that has occurred at the substation. We will need maybe a station level switch that can connect this information from this bay. If you've got other bays, this base will also connect to this network switch. And then from this network switch, number 6, we need a configuration for it to allow this communication. We move to the SCADA switch. Just as number 5, we need a specific configuration for that switch to make everything work. And then from there, the substation gateway or RTU will get the information that is coming from the breaker IED. So if you look closely here, the information starts from the breaker IED through the base switch, transformer base switch at number 5, to the protection IED number 4, through 6, and again gets through 5 again to 7. So it takes a lot of routes to get there, and to get there, all those configurations must be done and managed properly. And then the information from the gateway also through the switch can also be communicated to number 8, which is an HMI that can be used inside the control room. And then lastly, we bring in more complication. If the information of the process bus is in a different network as called VLANs, then to the information in your station level and whatever information you might be communicating, you might need a router there at number 9 to do inter-VLAN routing or to route information and segregate networks within your substation. So those 9 components now are very critical, that each and every of those devices must have a configuration that are synced with each other for a basic trip to occur in the system. So without a proper configuration on number 5, which is the transformer base switch, protection will fail. We will not be able to open the breaker. So it is imperative that those configurations are managed properly. Now, to expand further and just zoom in on a protection device due to limited time, I'll focus on the protection IED and the configuration. So the protection IED configuration contains many parts, and which are very important and must be managed. The first is the software. So it is important because we've got different vendor softwares. The 6150 standard made interoperability possible, but we still configure the devices using vendor-specific or proprietary tools to do the configurations. The first part that is important for you to manage is your software. You need to have the correct software. The second one is managing the software version. And then lastly is the device firmware, because it is important for you to create the configuration on a correct software. After creating it on the correct software, it must be the correct software version. Once you have done it on the correct software version, it must be also compatible to the device version in which you want to send this configuration to. So all these components are important for you to manage and look at and understand thoroughly. The second part is within now the software. Within the IED, we've got logics, we've got the AND gates, the OR gates, the algorithms that talk about diff protection, restricted earth fault, breaker fail, switch on to fault, and all those things. Each and every vendor uses their own proprietary tool. Although the 6150 standard has enabled priority interoperability, we still use proprietary tools to create these configurations. And now it's a complication that we must learn all vendor configuration tools and understand them thoroughly. And also now, these files that are produced from the vendor tool, each and every vendor provides this configuration in their own proprietary file format. After we have created the logics and functionalities, we get to the protection settings. So within the configuration, we've got a component of protection settings. This is where we set limits to say, where will our diff pick up? Where will our overcurrent pick up, our high set pick up, and those things. So these settings are also now within the device done on proprietary tools with a proprietary file format. So each and every vendor has got their own file format that they can produce for settings. Although there's some sort of files that are common that are used in the industry, a common one is XRIO that has been used by a couple of vendors. So that makes a little things better. But we still have configurations that are done on proprietary tools and the proprietary file format, which now inhibits interoperability a little bit. And then for communication, on top of the same device, we have another component which is communication parameters. As Engineer Carl has covered, the 61850 standard now, part 4 manages the management of these files. And then the part 6 of the 61850 standard now provides the configuration file format, SEL, and it also covers how we should manage these files in different components, to start from your SSD, your ICD, IID, ICD, and then lastly to the CID when it's configured. So that whole life cycle tells about where in the life cycle is the configuration. And then lastly, which is outside of the IED, but is very important for the IED, is the automation part, which is the configuration of the switches, the tools, and then using multi-vendor switches and those. So those are the configurations that we need to manage. And this is just related to one IED. So I'll just use the numbers that are close to the accurate. In NTCSA, we operate 200 substations with an average maybe of 20 bays per substation, and each bay has about 5 IEDs. So if you do a calculation there, we've got about maybe 100,000 configurations that we have to manage. So on that 100,000 configurations, I'm just referring to a complete configuration. You have to split it again, because now we still manage IED logics as a separate file. We manage a protection settings as a separate file. We manage the SCL as a separate file. We manage the automation of switch config as a separate file. So if you've got those 5 files per IED, you have to multiply that 100,000 by 500,000. So we have 500,000 configurations to manage. Now, this becomes a problem and needs proper strategies and ways to manage them, because the configurations are just not for storage, but they make protection operate. They are important for us to be able to monitor and control the grids. And then now that number that I've posed brings about a couple of challenges. One of the challenges being, the technical challenges being, we still have multi-vendor interoperability and proprietary tools. So each and every vendor has their own tool to configure the devices. Technically, maybe it might be tricky to get an interoperable tool for all the vendors, but maybe we can start with the file format. To have an interoperable file format and managing the configurations in a similar manner for all vendors. The second one is the complexity of the SCL file handling. When you have a system where some vendors can produce a CID file, some can produce a SCD file, some produce ICD files from their tools, you now have where you can create configuration on a single ID device with no validation to the other devices that it's communicating to. So if you make a change on one of the devices, the other devices might not know or validate about a change that's needed on the other devices, and you will lose your interoperability within the operational system. The third one is the version compatibility. As I've shown there in the overview of a PAC system, is that for a trip to be executed, once you have a fault maybe on a transformer, for that trip to be executed at the breaker, we need the version of configuration at the measurements IED, the one that's going to take the current and voltage to determine it's a fault, go into the network switch, go into the protection IED, and then lastly, go into the breaker to be in sync. So the version of configuration in that whole chain must be compatible. Otherwise, we will have a disaster within the substation. The transformer will not trip just because the version of config on the breaker IED was not in sync with the other ones. And then lastly, this challenge technical comes up also with skills on protection engineers, because now for the system to operate, we have a Ethernet network dependency. So we cannot operate our sample values or our goose messages without configuring the switches in the proper manner. So that's a challenge that we need to maybe move away from or improve on, understanding networking, implementing networking principles in a proper manner, and managing those configurations. And then secondly, we've got operational challenges. So like I've shown as well, the number of configurations per device has increased. So the first point there being change management. If I change a configuration on a network switch, or I upgrade firmware of a network switch and now does not allow VLANs or MAC filtering so that the goose or the sample values can go through the switches, I can cause operational issues. If there is an error on a protection ID that I misconfigured, or I send the wrong configuration at the wrong time, the error impact is huge. The whole system now is inoperable because an error of one of the actors within the whole system. And then thirdly, testing complexity. Unlike in the hardwired system, so we needed a multimeter. We just measure there if your trip output is coming out. You just want to look if there's a voltage on your trip output of on an ID to check if the trip is coming out. Now, to test the same thing of a trip coming out using 61850 systems and those things, is you must have an overview of the whole configuration. You must understand how the network is configured, the device sending what is the device configuration, and the receiving device, what's this device configuration, in order for you to do that. And then lastly, the documentation gaps. So we've got an issue where configurations only exist on the device. So if I'm busy working and then I find that my configuration is missing an OR gate or an AND gate or whatever, I add the OR gate, I manipulate, I invert or do anything on the configuration, and that configuration does not have any documentation or design that said there is a requirement for an AND or OR gate. So that brings about complications. If we lose the device, we have lost the configuration. And because it was not documented, if I'm not the one who is going to replace, then I would not know that there was a configuration that only existed on the device. So this is very, very, very critical, and we must move away from creating configurations only on the device. A configuration must start with a specification, a requirement, or anything on document, and from there will be transferred to the device. Even if we lose the configuration, even if our server collapses where we store the configurations, we have a documentation that can bring us back to the same situation we were at. And then lastly, it is the management of configurations. Who owns this configuration? If I've got protection settings and I've got a protection settings team that calculates settings, and then I've got a team that does automation, and then I've got another team that's doing logic, who is the ultimate owner of this configuration? So those are the challenges that needs to be mitigated, to have a clear structure of who owns what, so that should there be an issue, there can be accountability. Secondly, knowledge retention. I think also Engineer Carl covered that about knowledge retention. Knowledge retention, in my opinion, also ties down to documentation gaps. If the knowledge is in Ronnie's mind only, that is a problem. So we need to move away, that the knowledge must be in Ronnie's mind. The designs must be on paper, so that should any person come, a new person, new skills, we provide documentation so that they can be able to use that to get up to speed with the information. And then we've got another issue of backup and recovery. A month ago, I was called by my previous employer about a configuration I did 6 years ago. At that time, we did not have any systems to store configurations. He hoped I still had the configuration with me because they needed it. So this is now a very critical that we need to manage. Where do we store the configurations, and can we recover them when we need them? And then with that challenges, maybe I would like to propose a few mitigations and conclusions. Firstly, is we need to introduce or use a centralized configuration management system. If you are managing around 500,000 configurations centrally for all substations, those cannot be managed on an individual's laptop. So they should be on a server, on a system somewhere, so that each and every stakeholder of the configurations lifecycle can access them at any given time. Yeah, I don't need to be called to say, can you send me the configuration or that, or someone who has the configuration has resigned. What happens? I've had instances integrate into municipalities or metros where contractor or system integrator did the work, they left. The device failed 2 years later, no one has the configuration. You can't access the device or do anything to the device. The second part is...
Engineer Rooney, you're in the Q&A time. You have 5 minutes left.
Okay. The second one is the document there's a philosophies or standards to create configuration. So that configuration that you create, there must be a standard, a requirement, a specification that tells how to create it. This is a challenge I experienced when I was a young boy. I used to dismantle all my toys with the idea that I'm fixing them. But after I've dismantled the toy, I could not get it back simply because I did not have the document or philosophy of how the toy was created. And secondly, lastly, and I think this is the highlight, to propose maybe to OEMs that to standardize the setting file format, maybe to use the SCL format. I think the devices, the 6150 standard has already created a framework. It's possible it can be done. And also now the IED configurations to be able to be saved in a SCL format. There is one of the OEMs that already produces IED configuration files in SCL format. This will make it easier that we do not manage a lot of number of configuration files. And then lastly as well, in addition to the IED configurations, so for the vendor tools maybe to be standardized using IEC 81346-2, in that the ICT should be able to produce a file that will have a structure of a substation, voltage, bay, and the IEDs within there, so that I do not manage a configuration for each and every IED. If I've got 5 IEDs per bay and I've got 20 bays in 200 substations. So if I'm managing a file for the whole substation, that will make it easy to manage the configurations. But the highlight of my presentation is about proposing to the OEMs to produce a settings file and IED file configurations, maybe in SCL format. And I think it's possible the SCL, the 6150 standard has got a framework for that. Thank you.
Thank you, Engineer Rooney. We have about a minute and a half, 2 minutes. Maybe we take 1 or 2 questions. Engineer Arul, the floor is yours.
Thank you, Marwa. Thank you, Rooney, for the nice presentation, covering the interesting topic about the data configuration management and protection automation control system. We have a lot of questions in the Q&A section. I will pick up random questions. I'll start with first question from Kobus van der Merwe. Hi, Rooney. You talked about managing your PAC system utilizing IEC 650. How do one manage IEC 620 configuration versions in a substation equipped with multiple protection bays? When the update is done on a single IED, you know, the other subscription devices are now operating on different versions that also need to be updated. This is not always possible due to the risk of tripping live operational plant with IEDs rebooting after updating. Do you have any comment on this question, Ronnie?
Yes, that's a very tricky exercise and sensitive and should be managed in a proper. If you've got IEDs that are communicating with each other, maybe via Goose, and now you want to modify the configuration on one of the devices that will affect the SCL file, you are then forced to also update the other device with the updated configuration, because if you do not do that, you will lose your Goose communication based on the confref. So whenever you take on such a task, you must have a proper outage, segregate the live parts and the parts that you are going to work on. I do not, what is this, then promote that you do such exercise in a live substation, because you can cause unwanted trips.
Yeah.
So it is best that you only change the configuration of the device that you've got an outage booked for, and provided that configuration does not affect other devices. If it affects other devices or base, those must also be booked out for an outage.
Yeah, that's the best practice. I appreciate the comment from your side. We have a lot of questions received. Because of the
Yes.
time limit, we will take it to you later,
Okay.
Ronnie.
Yes, apologies about that. And thank you, Engineer Rooney and Engineer Arul. We'll send you, of course, all the questions offline for you to answer. Now we'll go on a 20 minutes coffee break, get a drink, stretch, and come back refreshed. When we return, we'll travel virtually to the University of Bahrain for a very special edition of the Young Engineers Integration Dialogue by Omicron. This session will be streamed live from the University of Bahrain campus, where we'll be joined by electrical engineering students. Tune back to learn more about a unique internship opportunity offered by Omicron. See you again in 20 minutes.
Thank you.
Thank you.
Arul, can you hear me? Just wanted to check if my audio is okay.
Welcome back, everyone. We hope you enjoyed your break. Let's now head over to the University of Bahrain, where we connect with Engineer Ahmed Al Hamai, Regional Manager of Omicron MIA. Ahmed, the floor is yours for an exciting edition of the Young Engineers Integration Dialogue from the University of Bahrain.
Thank you, Marwa. I hope I'm audible to everybody. Yes, I got sign. So good day, everybody. Good day, everyone, both here at University of Bahrain and also joining us virtually across the Middle East, Africa, and Turkey. It's a true honor for me today to open the Young Engineering Integration Dialogue by Omicron. Today, we're not talking about the future. We're talking to the future. And I hope you remember this very well. We're not talking about the future. We're talking to the future. Starting by big thanks to University of Bahrain for giving us this opportunity to be here with you, with the future, in the same room. Engineering is evolving faster than ever. Talking about artificial intelligence, smart grids, renewable, digital twins. So the set of skills engineers need today is much more than the academic skills only. But you must get equipped with so many skills like adaptability, creativity, and mindset of collaboration, because no one can do it alone. This session is about to bridge the gap between the academic and the industry. It's about understanding what skills truly matter when you get into the industry. It's actually how would you know the industry can support you? What actually we expect from your side and how and where we're trying to find you. And also it's about you to know what skills and what action you should start working on. Today we are joined with brilliant mindset on the stage. I'm so proud to be here with them. A respected assistant professor, Dr. Fadl from Electrical and Electronic Engineering Department. Thank you very much for being with us, Doctor. A key voice and the Director of Alumni Affairs, Mr. Mahmoud. Thank you very much for being here with us. And also Engineer Muhammad, working at Omicron, and he left the classroom to the industry shortly, and he also bringing that voice. We would like to go in the insights from everyone's perspectives, and at least out of this session today, get with one action for you to do. So remember, you should get one action for you, only you, to do it for yourself, to bring yourself ready to the industry. Let's get started, and I would love to ask Dr. Fadl the first question today, which is actually from my side. What are the most critical technical and soft skills you believe the students today should focus on to be industry ready?
Also, we have another skill, which is adaptability and lifelong learning skills. Real life is always changing, so don't expect once you graduate things will be same as what you have learned. So you need to adapt to changes, and you have to have the willingness to learn continuously. So that's why we teach you how to learn, okay, and continuously by giving you exercises during the university time so that you can get skilled in those in gaining knowledge by yourself. Okay. Another skill that is very important is the teamwork that you have mentioned and collaboration. It's not enough that you know how to learn by yourself, but also you need to know how to collaborate with others in different team settings. You take responsibility of your task, okay, and should be reliable and working with the team. Also, you need to know how do you give and receive feedback constructive feedback when you are working in a team. There are other competencies related to working ethics, time management. So there are so many other skills, but this is in a summary overall skills, knowledge, and competencies.
Cannot agree more, Dr. Fadl. It's impressive really to see all this set of skills in mind, and I hope it was reached well as a communication now, we said. And we move now to Mr. Mahmoud to ask him actually how does the alumni network support young engineers in their early careers?
Yeah, first of all, I would like to thank Mr. Ahmed and Omicron for this great opportunity to meet all this distinguished guests and our students. To be honest, this is the first time for me after I received my promotion to be a director of Alumni Affairs Directorate. So it's the good chance to be with you live, to inform you and to keep knowledge about our services and the programs, which we would like you to participate and sharing your thoughts, skills with us to improve your professional skills instead of the academic skills with Dr. Fadl, what he missed. Okay, we have 4 pillars here. We have the Skills Up program. Skills Up, it's already start with 21st century skills, which already consists of 4 levels. The first level talking about the general skills. Second level, it's already talking about the soft skills. Third with the hard skills. And fourth with leadership skills. This programs we provided to our students to skills up to be ready for the job market, inshallah. Also, we have the mentorship program, I think. Inshallah, we have Muhammad as a mentor, our future mentor for you, inshallah. Also, we have the site visit to the live and coordinate with the faculty member of College of Engineering. Also, we have the Career Day Fair, which invite all these companies in engineering field you to hold S18, inshallah, and next February, we invite you to be there to meet all these companies. Also on the second pillar is the internship. Third, we have employment support. And finally, we have alumni tracking. This all services we created, we developed to help you to be ready to the job market, inshallah. But without your cooperation with us, we cannot do any progress of improvement. So this in general. Yani.
Thank you very much, Mr. Mahmoud. It's really, I can just add one thing to Mr. Mahmoud's answer now to you. My first job I got 25 years ago was in one of these career days. exhibition. So really take it
So,
serious.
You are my mentor, inshallah, after this session, inshallah.
Thank you. Thank you very much. And for Engineer Muhammad now, hearing all the skills needed, the support from the alumni, how about your experience for the biggest challenge you got transiting from university to the workplace, and how did you overcome it?
Thank you, Ahmed. First of all, I would like to thank you for this opportunity to be in this stage. It's an honor, to be honest. And if I'm thinking about the biggest challenge transitioning from university to a workplace, there are a lot, to be honest. But if I would mention one, I would say the biggest one is the awareness of the market requirements or the industry requirements for me to be integrated in the industry. So as Dr. Fadel mentioned, there are a lot of skills, a lot of sets that can be developed in order to enter certain markets, enter certain industries. And there are a lot of specialties and subfields within the electrical engineering with a huge knowledge and experience. And as a student, it looks like a maze, right? So I have this field, I have that field, I have a lot of fields that I can, let's say, develop a skills or develop an education in that field. So I would say that's one of the biggest challenges as a student. And maybe I can mention some examples. I remember I was hired as a maintenance engineer in one of the companies, and I was asking the manager, I would like to do engineering stuff. I don't like to do like normal stuff, technician stuff. No, I really want to do engineering stuff. And he was really open, and he told me, Muhammad, we have a new project where we have a new substation designed by a consultant, and we need to approve it. So in order to approve this design, you need to know the standards. You need to know the requirements for this design. You need to know the local standards. You need to know the internal requirements for the design. And I was looking at the design. I'm like, I have no idea what is this. So these kind of skills, these kind of, let's say, specialties in the field, I think as a student, if I am aware about it, that there are different fields requires different certain of skills, different certain of knowledge, different standards, then I think I can make it as a start point where I can move. Like, for example, I will go in this field or that field. I need to develop this certain of knowledge or this certain set of skills. Yeah.
Thank
That's
you.
it from my side.
Thank you, Engineer Muhammad. And that can circle back to Dr. Fadl, actually comment about the foundation of the principles of engineering. So whatever you will get in the first time, you might get shocked. You didn't know anything about it, but you go back to your books and curriculum, and there's some stuff you studied already in the university. It will give you the first clue, right? And that takes us to the next question to Dr. Fadl, actually, about the curriculums. How it's evolving to adapt with emerging technologies, IoT, cybersecurity. How the university cope with that?
Basically, university programs are in continuous development. So it runs or it goes through a periodical internal and external reviews in order to improve its learning outcomes and meets the diverse industry needs or evolving industry needs. As the process of program development could include market study, see what the industry needs. It includes benchmarking with other highly reputed program regionally or internationally. Also, it includes the compliance with international standards to assure quality of our programs, such as ABIT, accreditations or local placement using, let's say, compliance with the National Qualification Framework in QF. So all of this process trying to ensure, I'll just give you an example in our program, in recent development that we, one example for the electrical engineering program, another example for the electronics engineering. In the electrical engineering program, we used to have renewable energy as elective course. Now, Bahrain skills, they specified that renewable energy and sustainable energy should be a must, no. So that's why we had decided to change this from elective to a core course now in the program. Another additional in the electrical engineering is the smart grid. So now we have a course that covers the smart grid in our program. So this is with respect to the electrical and the electronics engineering program, for example. Because of this review, we have courses in artificial intelligence, IoT, as part of our program. So this is because of this continuous improvement, trying to meet the industry needs and upskilling the student learning outcomes. So.
That's impressive. Thank you very much for sharing such processes. And again, that's a link for the industry side we didn't know about. So really appreciate it. And I hope all the audience and virtually as well, they get to know more about that processes within the university. And again, that takes us to Mr. Mahmoud. Again, he talked a lot about mentorship inside words. And is there any mentorship or internship programs that the students should know about?
Yeah, I will summarize the answer to take the benefit of the time. First of all, we have 3 types of the internship programs. The first is the mandatory internship, which is required for graduation. The second one is voluntary internship, which you can agree with any company, any ministry. We will help you with will give you the certificate which allowed you to train there without fees. The third one, it's subsidized training or internship. Now we already trying to do it with Tamkeen and Ministry of Labor, which is allowed the student training and from 3 to 6 months, and he will paid from Tamkeen and also the Ministry of Labor. For the mentorship, inshallah, on 2026, we will arrange or improve our program for the mentorship. I would like to say that Mr. Muhammad, inshallah, will be the first mentorship of our student. Yeah, and I would like you to be collaborate with us, inform us about your requirements to fill these requirements, inshallah, in the future. We are open to that.
That's a great news. That's a great news, including also the update about Engineer Muhammad. It couldn't be better connection between the engineers and the academia. Quick question to Engineer Muhammad now about actually what and which skills or experience from the university help you the most in your current role?
Yeah, I think the knowledge and the continuous development and the knowledge of our courses and semesters inside the university helped me a lot to build a foundation, at least. Once you have the foundation, then you are in the workplace, in the industry. You can build that experience that needed for that industry on the foundation. That's why I always advise students, don't take the courses as just to have excellent grades or just to pass it. No, this is a knowledge that you need to take with you into the industry. Don't just study for the exam to get an excellent grades. That's good. That's great, actually. But get an excellent grades so that you have the most knowledge and the most strong foundation that you can have to bring it with you to the industry. And then you build on it. You build on it in different fields and different specialties. So I think that foundation helped me a lot. And of course, the advices from our professors and doctors helped me a lot as well on how to integrate in the industry. So yeah, I think that.
Thank
that's-
you.
Yeah.
Thank you, Muhammad, and being a mentor as well in the future, so you can see the hope now. And exactly everybody listening to us as well here in the room and virtually across the region, you might find as well ways to find a mentorship or internship. There is a lot of things that you need to work on, actually, to know where is it. And from this session today, we know what's going on in the University of Bahrain, but wherever you're dialing in from another country, reach out to the universities, reach out to the alumni, reach out to your colleagues or the industry, social media like LinkedIn and so on. Try to do your part of the job and don't just try to blame others for whatever going on, but actually there is a lot of part about it from your side. And I would say if there is any question now from the virtual room, or I would say to take it first, because we will continue here with you for another 30 minutes without the more than 700 dialing in from other countries. So I would give them the floor now and say back to Marwa if there is any questions in the chat from our attendees. Marwa, back to you.
Thank you, Ahmed. Am I audible for you?
Yes.
Thank you so much for a very interesting session to know the programs of the University of Bahrain. So we do have a couple of questions. One is from Engineer Zohaib Ali, where he says, our academic records are not so strong, but we have skills, strong skills. Unfortunately, to enter any industry, an outstanding academic career may be required. So how can students with great skills shine that through, basically?
I'm not sure if I get it. No. Can you repeat it again, Marwa? We didn't get it here, sorry.
So his question is, there are some students that they have academic records that are not so strong but have excellent skills. How can they build on that skills and promote them to enter the industry?
So did I get it right? They don't have good academic skills, but they have good social skills, kind of, or soft skills, right?
Exactly.
Okay. I will give my hint quickly, and maybe also I will ask the panelists to answer. For me, if you're working in engineering, you cannot go without academic skills. No way. Forget it. There is no shortcut. The core in any engineer heart is the foundation, is the science, is the basics principles. Otherwise, it's really, sorry to say it blindly, ridiculous to even think about it. Because you need to work hard in your academic skills. If you will work in the engineering field, you need to know what you're talking about, because actually it can cost us lives of people, right? Especially talking electrical engineering. Huh? But if you will go in another career, that's fine. It's your decision. But if you plan to work as an engineer, there is no way to go without the foundations. If any other comments from you, sir?
Yeah, I agree with you totally. Your education will not be recognized unless it is certified by education institution, and one has to go through this, the universities or colleges or to get this certifications. And despite, still anyone can learn from the available resources, books, webinars, or short courses, but that's not sufficient, unfortunately. Yeah.
Okay, any other questions?
On that note, we do actually have a question that is related from Engineer Collins. Please, what certifications can you advise to advance in your career in power system protection?
Anyone would like to? Yeah, certifications needed to advance in the power system protection. Yeah.
I can add one at least. So for example, there are different utilities and industries that requires you to have a certain certification to do some kind of testing on their protection relays. So for example, if I am the utility, I am the owner of these protection relays, I need a contractor to do this kind of testing on these protection relays. I need someone who's certified. For example, we have certification for using CMC 500 to do the protection testing. I need someone who's certified to do the test kit and has the enough knowledge to do this kind of activities without damaging my assets, right? So that's one example.
There is also certification from the manufacturers, like as Engineer Mohammed said now, for example, Siemens, for their protective relays, you might need to go through some training and test to get past exams, and then you have a certification with you in hand that show that you can configure and make a setting for such relays. And this certification, by the way, it is not valid forever. You have to renew it every year or other year. That makes sense that you're still up to date and know what's going on in the industry. In Omicron as well, for kind of partial discharge and so on, now in Saudi Arabia as well, there is a certification over there. You need to get a training, then certified, then you can use the products safely on site. So there is also certification from institutes like Saudi Engineering Society, for example. I'm assuming there is in Bahrain as well, and other countries, that you cannot start practicing engineering before getting this certification, which is actually after the university degree. Very good questions. Thank you very much for that, because it opened a good discussion in the room. Any other questions?
We have 1 minute, maybe the last question. What's the difference between a trained and a certified engineer?
Between?
A trained and a certified engineer.
Trained and certified. Anyone would like to answer this, or should I go for it?
You can go for it, but I think it's obvious. Trained is a trained and certified is. So certified has this set of skills to do this activity and has the background knowledge. And of course, he has passed the exam as well. Trained, he might be just training to do that, or practicing to pass the exam, for example. Just an idea for myself.
I think certification is just giving a stamp on a certificate, okay, or a license. While training can do training without getting a certificate that prove that you have met the required skills and you passed the test, or so certification it needs somebody to test and get a certificate that approves that he has the required skills.
That's totally true. I mean, like, a very good question, to be honest, and it always concerned in the organization, because sometimes you can provide training, but you cannot provide certification. Because to provide certification, you need a credit to be actually able to give the stamp or certified. And from the organization we're working in now as Omicron, there is so many courses we say that's a training, attended training, but not certified. You know what I mean? That's a big difference, and good question again. And if you need the stamp, you might get this training from accredited institute that can make you certified engineer to perform a job. But if you want to get training to learn and improve your skills, you can get a certificate calling that attended this training. There is a difference. Yeah. Thank you for the question. Any other questions? But I think we have no time, I believe.
Yes, unfortunately, we ran out of time. So thank you, Engineer Ahmed, for moderating this session. Thank you to the University of Bahrain, represented by Dr. Fadel and Mr. Mahmoud, and as well to Engineer Mohammed, saved from Omicron. It's inspiring to see this integration dialogue and the effort and commitment to integrate students and young engineers. The internship opportunity mentioned is a great example of how PSquare and Omicron actively plays a role in this integration. We'll share the application form in the chat and in the follow-up email, and you can also scan the QR code that is coming up in a moment. So do not miss the chance to win an Omicron one-year internship, and that can be done by attending virtually 50% or more of the event, or attending physically at the University of Bahrain. You graduated between 2023 and 2025, and you filled the form in full, including submitting both your CV and cover letter. We wish everyone the best of luck. Goodbye from the University of Bahrain, and now we move to Engineer Arul Raj Sami. As Engineer Ahmed Rabbani isn't able to join us today due to an urgent matter. Engineer Arul, the floor is yours for a hands-on session on protection testing using IEC 61850. Engineer Arul, the floor is yours.
Marwa, do you see my screen now?
Yes, please go ahead.
Perfect. Okay, thank you, Marwa. And for the introduction, what are we going to see for our next 20 minutes? We are going to talk about hands-on protection testing using IEC 61850 applications. For the practical demonstration, I will give you an example of a small setup I do have here with me. The idea and the test is the protection relay, protection control on automation ID from Hitachi. It's an RED 670 to 2.7. And this particular ID is configured for protection function, control functions, also measurement functions. And we also configure this ID to publish goose message, especially the protection start and trip. And this protection trip and start information will be subscribed by CMC 500, which is in my setup. And the CMC 500 will be acting as a merging unit because I don't have the real merging unit in my setup. But the good news is we can simulate any different merging units from Test Universe using CMC 500, also RelaySim test, but in this case I will use the Test Universe software application. And I also use the IEC 620 client server module, which is also one of the module from Test Universe. As a client, I'll be collecting data, enabling reports, also pull the value, also send a control command to the ID, which I'll be explaining in the OCC file how to set up quickly. Next, to synchronize the device under test, also the test equipment, which will be using as a merging unit, using OTMC under P. OTMC under P supports PTP and NTP. The OTMC under P is basically the PTP Grandmaster clock. And we have a Denio 400 for network and communication verification. And I will be using Denio control software to manage the Denio 400. And I have MBX2. If you have enough time, I will also show the station scout and ID scout, how we can manage it to verify the control functions, also the goose messages quite easily. Next, most important device, which is Ethernet fiber switch from Hirschmann, RSP20, which is basically connecting all different devices. And the switch is also acting as a PTP transparent clock in this setup. So let's go directly to the practical setup. So this is the device under test, which I was explaining, RED 670. But let's come from the source. The source is basically the SAM600 PAU, process interface unit, which basically have the analog input modules, like a transformer modules to receive the current and voltage information that are coming from the secondary side of the CT and VT. And this ID is configured to convert the analog current and voltage information to digital sample value streams. So here is the sample value dataset, which includes basically the 4 current and 4 voltage in the sample value dataset. And I also used the default sample value control block. Most importantly, for the real project, it's highly recommended to use the project-specific sample value ID to make it more easier. Also, the VLAN ID to pass the traffic in a right way to be able to deliver the sample value and goose applications to the destination devices. Next, I also associated the source information to the destination devices. So we have one destination device, which is basically going to subscribe sample value, which is our ID under test, RAD670. And I will go to the application configuration. So here is the signal matrix analog input. The input is coming from the merging unit. And we have two signal matrix analog input, one for current, another one for voltage, and the three-phase current and three-phase voltage informations are connected to the overcurrent protection function block, and the trip information of the overcurrent protection function is also connected to the circuit breaker open when there is a fault, and the circuit breaker will be opened automatically. I also added the measurement function because we will be doing digital wiring check, because when we wanted to start proceeding with protection testing, first thing first, we will check the CT ratio, VT ratio is properly set. The relay is measuring the proper current and voltage information, which are injected by the test equipment. So we will be using the VMMXU, CMMXU function blocks, which output the current and voltage information. We also calculate the power system parameter based on the three-phase current and voltage for the active power, reactive power, and frequency, so the power factor, and so on. Also added the disturbance record function to be able to get the disturbance records when there's a protection trip and start happens, including the breaker open close status. Next, I go to the data set for the goose message. For the ID and the test, we do have one data set created, which include the protection start for the stage 1 and the protection operated signal for the stage 1 as well. Next, the goose dataset is already configured for publishing to the goose control block. And as I said before, for the actual projects, it is highly recommended to use the unique multicast MAC address and the project specific dataset, also the VLAN ID, to be able to pass the messages to the destination devices in expected interval. Next, I will go to the client-server communication. So the reason why we do wanted to also focus on client-server communication, we do have a dataset created, and this dataset also include the current and voltage informations, also many other power system parameters. Because we'll be injecting current and voltages from the test set, automatically we do perform the assessment using the client-server module. And we do also have one more data set created that includes the protection start and trip information. And we have one data set that also include the breaker open close status information. I will be using it for getting the feedback when there's a protection trip happened, whether the breaker is opened or not. So this is a quick overview regarding the communication aspect, but just to give you one more insight. The ID and the test have many different access points. One of them used for a station bus, where we have the client-server communication, and the access point 2 is usually dedicated for my setup for sample value subscription. And the access point 2, we are also synchronizing over PTP time source. Next, I go to the merging unit. So here we have the, once you associate the sample value from the source to destination in the i620 configuration tool for the process bus, automatically the mapping is done within the ID configuration tool from PCM600, for example. And you can see already the sample rate which are defined in the source ID. Automatically it comes here. We are using just one sample value stream here to subscribe for this simple non-directional overcurrent prediction function. So let me go to the prediction setting just to give you an overview. So I have enabled two stages. The stage one is non-directional, and we have IC definite time and setting, and the setting value is 180% of the I base, meaning that the I base value is you can see in the power system. So I'm using the global base value 1. So the CT ratio is 1000/1, and the VT ratio is 220 kV/110 volt. And I come to the prediction setting. So when I inject beyond 1.8 ampere in the secondary, you should be able to expect the trip from the prediction relay. And we have a time delay for 500 millisecond for the stage 1. And for the stage 2, an example, we have also enabled non-directional IC definite time. The setting value is 600 percentage of the I base, meaning that if I inject 6 ampere in the secondary, we should be able to also expect the trip information from the relay. For the time delay for stage 2, I have kept 100 millisecond. This is a protection function that we have just configured and enabled, and I already wrote the configuration to the ID and the test. Next, I think I have already exported the SCD file, because as you know, the whole topic is all about testing protection function using IEC650 environment. The whole day we also talk about, from the beginning, 2 sessions, the importance of the SCL file. So you can basically export the SCD file from this level. I have already exported the SCD file of the project to my desktop. You go back to the TestNews. It's already opened, and it's highly recommended to use the OCC file. I have created the OCC file already, but I will just give you an overview on how to set it up. So first thing first, you need to define the device under test, the test object. So you can define the frequency required and the VT ratio, for example, 220 kV and 110 volt and 1000/1 ampere for our setting. And you can also fill the left side part for better test report management. For this time, I skip the other part. And this is very important for publishing sample values from the CMC test set, especially when you wanted to use TestNews 4.40 above versions. The hardware configuration tool introduce the new way of associating the test set to manage the CMC 500 and the old test set as well. So here are in the Omicron device link, you could see already the number of Omicron test set I do have in my network in the PC I connected to the switch. You have to choose the test set first and then associate the test set. And next, as you know, we are going to use the sample values. I prefer to disable the analog current and voltage channels. Instead, I prefer to use the sample values for set of current and voltages. I enable it for measurement and non-directional overcurrent testing. Once you enable the number of channels for the sample value that you wanted to use it, you can next proceed with the configure option. So here you can, by default, you see like this, and you can click the SCL import, and you go to the desktop where you exported the SCD file. And the TestNews sample value configuration module having the intelligence to pick up the ID that includes sample value stream. So these are the IDs in the PCM project that support sample values. And what are we trying to do? We are trying to use the SAM600 PIU. So this is a sample value ID, and I click OK here. Next, you need to also make sure the test set that we are using is CMC500, and we have Ethernet 2, and we need to choose the right Ethernet access point for publishing the sample value. Next, as I'm in a test environment, I can able to uncheck the simulation flag because I will be using the CMC as a real merging unit in normal mode. Next, I can able to pick up the sample value IED, and then I can choose the sample value rate, the sample rate. So for example, in our case, we are going to test the prediction function, 80 samples per nominal period. Next, I go to the stream 1 because we just enable only one stream for now. Next, I go to the stream 1. You see already the sample value configuration module pick up the data from the SCL file to simplify things for you. And next, you click the dataset mapping. Then you need to map the CMC channels to the sample value data attribute. You have to map one-to-one the current and voltage channels. Next, you can click OK here, then OK. You can also use the optional field if required for your ID and the test. But for now, I'll skip it. Next, I go to the time source. As you know, it's quite important to make use of the PTP as a time source because we'll be using CMC as a merging unit. We can also pick up the right Ethernet access point, and automatically the CMC also can synchronize. And I'm using the PTP profile based on IEC659-3. And this is what I also enabled in the OTMC under P. I just wanted to just show you the OTMC under P web interface. Here you can see the clock is already locked and the configuration is already enabled to be acting as a PTP time source based on the power utility profile. And you can also switch different profile based on the requirement. And you can also define the domain number priority flexibly as you required. And this setting is already done on the ATP Grandmaster clock. It's our OTMC 100P. Also on the switch and the instrument, we also enable the transparent clock setting for all ports. Next, so uncheck check the accept inaccurate Grandmaster clock because I'm in a test environment simulating the PTP time source. I click OK here. Next, you can start with Goose configuration module because we'll be subscribing the Goose message. You can choose the right Ethernet access point for subscribing the Goose message. You can click import SCL file. And the Goose configuration module also having the intelligent, even if you pick up any big SCL file, it will pick up the right IDs that include the Goose control block. You can uncheck all of them and check the right one. You remember in PCM600, the ID and the test include protection underscore signal G. This is our Goose control block where we have the protection start and trip information. I can drag and drop the protection start. So a binary input, I can also enable from the global hardware configuration, virtual inputs. We have 15 groups. Each group to include almost, we have 360 virtual inputs can be subscribed as a Goose message. Okay, you can also at the same time publish 360 Goose messages from CMC. You can drag and drop the prediction start information. Next, you can exit, and then you can also add the client server module. This is to check the measurements are okay enough when injecting like 20%, 50%, 80%, 100, 120%. For this, we will make use of the i620 client server test module. For this also, we need an SCL file. I pick the SCL file. And the ID in the test is the Q02A1. And you can also check the test connection. For example, test connection is succeed, meaning that the client server module from the testing piece having access to the ID through the switch. You can also explore the whole data model dataset for free using the test universe without having the test set. Next, you can basically add many different state as you required. And for example, here at the very beginning, the set ID, you need to make sure the ID and the test. So I have to load the protocol configuration. I forgot to accept. So the configuration has been loaded. I need to pick up whether I wanted to test the ID on the different mode. For example, if I wanted to test the ID in normal mode, if the ID is already in normal mode, I don't want to change the mode of the ID. I can keep it no change. If I wanted to put the ID under test mode, I wanted to conduct some test to check the behavior, then you can also change the mode at the beginning, and you can also further automatically complete a different state. And then you can also come up with enabling required report control box for expecting certain data from the reports, which are going to be sent by the ID to the client server module. For example, we will be interested to listen to the measurement report control block because we have heavy data, for example, and you can also add the report control block that include the breaker status, also the report control block that include the protection information. Next thing, you can, for example, one of the state, I will inject like current for 4 seconds, 5 seconds. And then I can also send a control command, for example. So this is a logical node for breaker. I can also send a control command like for the breaker and disconnect or any other equipment. And I can also expect the response from the ID and the test on different levels, meaning that you can also just check the report is received, or if you wanted to also check the report and dataset information should be tested along with that. And if you wanted to just pull the data, you can also use dataset data attribute subset. You can also go to the data model and pull the value as required. And let me close this part. And I also added in my test plan one more module. That's the Oracle test module. So here we can basically start with global hardware configuration. The test object, you can click the hover current protection function and the elements. You can also make sure that the ID and the test, what we have is enabled with non-directional overcurrent. You can also adjust the tolerance as you require. And next, we have configured with 2 stages. For the stage 1, the pickup value is 1.8 ampere.
Engineer Arul, you are in the Q&A time. You have 7 minutes.
Okay, then better I just run the, I just finish this and open the test plan. So I already prepared the test plan. I just clear it just to run it and show you what we have configured. Also bring the ID and the test just to show you when there is a protection trip happens, you also see the breaker. And before we inject the fault current, we also close the breaker. Once the fault current is injected, we see also the trip information, breaker will be open. Let me start the OCC file. The Goose message is already subscribed by the test set. Now the client server module is going to open. So you can see now the client server module, we are injecting 25% of the current, and we are expecting the actual value. And you can see the actual value, which are measured by the ID. Can also show you in the ID HMI, you can see it. And then for the different values that we are injecting in each step, each state, you can see the expected, and you can also see before each fault current, we are closing the breaker. When there's a fault current happen, breaker trips. Once the fault current is injected, and after that we are also closing the breaker, and we are again injecting the fault in different phases. Next, we are moving on to the overcurrent protection function module, test module. There we have configured 2 stages. And for the pickup and drop off, we are testing the stage 1 for the different fault type, single phase, phase to phase, and 3-phase fault, and single phase to earth. And you can also see the expected values, the actual value. Next, we are moving on to the characteristics test. We have configured many shots and easy to configure multiple shots. You can click add multiple and set the relative to which stages that you're wanted to create many different shots. And you can set the step interval for the 80% to 120% for the setting value. Automatically the overcurrent module create all these shots points automatically. So for example, we have 89 different shots on different phases. So you can fully automate the overcurrent prediction function, not just non-directional, including directional overcurrent prediction, also advanced differential distance in a similar fashion quite easily.
Engineer Arul, apologies. You have 3 minutes left of the Q&A time.
Okay. We can also take the Q&A now if you have any questions.
All right. So thank you, Arul, for this practical insights on IEC 61850. I now leave the virtual floor to Engineer Muhammad Ibrahim, who's joining us back today to moderate this session's Q&A. Engineer Muhammad, the floor is yours.
Thank you very much, Marwa. Thank you, Arul, for the practical session. Very interesting to see how to do something practical. It's not only just slide. We received a lot of questions, but I know because of the time. But let's start from the first question came from Mr. Sayyid Muhammad Zuhair.
Mhm.
Can we also use CMC 356 as a merging unit?
Yes, definitely. As long as you have the net2 communication module, you can basically make use of full benefits, meaning that you can have the support of latest enhancement improvements added to the test universe version with the latest firmware on the CMC. But even if you have all the communication modules like Net1B, Net1C on your CMC 356, yes, you can basically make use of all the functionality which I'm showing. But just to make sure that you have the sample value configuration module license, Goose module license, also the client server test module license if you wanted to perform the assessment automatically, like I shown in a small demonstration. In case if you do not have an license on your CMC, feel free to contact us from the support at omicronenergy.com email address, from the technical support on the Omicron Energy website. We will be happy to support you with emergency time license for you to try and then come back with the feedback. Even for the actual project, we can extend the license for the time license requirement.
Thank you very much, Arul, for the very detailed answer. Another question from Mr. Severino Tonguku. Can we change manually the polarity of the sample value if the polarity is wrong?
Yes, you can actually do it. Yesterday, this was the topic also addressed by Alex in his presentation. You can manage it from the hardware configuration module, also in the test object especially. So we are done with the overcurrent test module, and I go to the device under test.
I got the
I'll
information that
show
the
you.
time is finishing very fast. It's already finished.
Yeah,
Maybe
you can.
a short question, short answer, please, Arul. Mr. Richard Bubada, when the bus power protection system need to trip the circuit breaker, how does the signal usually get sent in the read live? How does the trip signal coming from the digital relay?
Okay, for bulb protection testing, like even we covered this topic yesterday from Alex's presentation. In digital substation, we heavily use the goose messages for protection trip. Of course, the bulb protection relays on the central unit need the disconnected status, breaker status for the zone calculation. So all these informations are generally passed over goose message. And the protection trip information also goes back to the PIUs or switchgear control unit at the process level to be able to extend the trip to the actual circuit breaker. All these things are done over goose message, and it is possible to use goose message. And you can also make use of the Omicron CMC test sets to publish goose messages. Also, RelaySim test is even more excellent, especially for system-based testing. You can draw the single line diagram as Alex shown in his presentation yesterday, and you can also simulate the equipment status quite easily.
Okay, thank you very much again, Arul. But I think now, because of you detailed answer, we will not able to take more questions, but for sure, we will collect all questions, share it with you, and I know that you will answer it all. Thank you very much. Now I hand it over back to Marwa.
Thank you. Thank you, Engineer Arul, and thank you, Engineer Muhammad. We will now go on a lunch break for 40 minutes, and after the break, we'll host again Engineer Arul for a panel discussion on challenges and solutions in implementing digital substation. Enjoy your lunch and see you back in 40 minutes. Welcome back, everyone. We hope you had a good break. We now move to a panel discussion on challenges and solutions in implementing digital substations with perspectives from Austria, Namibia, and South Africa. A reminder that the Q&A area is still open throughout the day for your questions. To moderate the discussion, please welcome back to the stage Engineer Arul Erodeyasamy from Omicron MIA. Engineer Arul, the virtual floor is yours.
Thank you, Marwa. So let me first talk about the interesting panel discussion topic. We will be talking about challenges and solutions in implementing digital substation. This is our main topic of the panel discussion. For 1 hour, we will discuss various subtopics under this main theme. First, let me introduce the panel members. I'll start with myself first. My name is Arul Erodeyasamy. You can call me Arul, and I have more than 11 years of experience, work for different companies as a system integrator. Also for IED development team, I also worked for a few years. At Omicron, I also worked almost 5 years supporting substation automation, testing and OT cybersecurity solutions in Omicron, Middle East and Africa. Next, I will start with France. France is currently working in NamPower, which is basically a Namibia Power Corporation. France is a senior engineer at NamPower. He currently leads a team of protection engineers within NamPower. As a team leader, he is responsible for safeguarding the utility transmission grid. His primary functions include protection automation control scheme design, protection IED configuration and testing. He's also responsible for transmission grid fault studies and analysis. France is a registered professional engineer within the Engineering Council of Namibia. His qualifications include Master of Engineering and Bachelor of Engineering in Electrical Engineering, both from Kazan and State Power Engineering University from Russia. Additionally, he is actively involved in SIGRI B5 working groups and the South African Power Pool Operating Subcommittee on the Regional Interconnection Protection Coordination. And next, we have Komatso Manapetsa. He's currently working in NTCSA, which is basically the National Transmission Company of South Africa, which was very well known as a ESCOM a long time. And Komatso is currently working as a chief engineer in control automation and OT cybersecurity at NTCSA. He's a professional engineer with ECSA, IEEE, SIGRI, PACWorld, CIEE, and SAIMC memberships. His expertise includes operational project management for undersea fiber optic cable systems, optimizing plant system, and leading critical system upgrades. Currently, his focus on cybersecurity, secure remote access system, and history and implementation in power utilities, encompassing secure communication and network design. A thought leader, he has presented numerous papers at SIGRI, IEEE, and PACWorld conferences and conducted South African IEEE webinars. I also attended his last webinar. It was very insightful for everyone working in OT cybersecurity. He holds an Master of Engineering, and he's a PhD candidate in Electrical and Electronics Engineering, focused on cybersecurity with extensive CompTIA certifications. And next, we have Diego Gasca. Diego is working at Omicron currently. He studied electronic and communication engineering from Columbia. Since 2007, he worked as a control and protection specialist, participating protection and communication, especially IE6OT projects that took place in different countries of South and North America. In 2016, Diego joined in Omicron currently is supporting part of the consultancy team. Basically, is supporting various utilities in digital substation projects around the globe. So this is a brief introduction about the panel members. Without wasting much time, let's get into the subtopics. So as you know already, the main panel discussion theme is it's all about challenges and solutions in implementing digital substation projects. And under this main topic, we have some subtopics, 4 of them be picked. The first one is identify common obstacles faced during the implementation of digital substation. Second one is share the practical solutions and best practices to overcome these challenges. The third one is innovative technologies in digital substations. And the fourth one is future trends and developments in digital substation projects. So let's start with the first subtopic. What are the common obstacles faced during the implementation of digital substation projects? Let's start with Franz. What's your opinion or comments on this topic, Franz?
Good morning, good afternoon, and good evening to everyone. Speaking to you from Nampower, Namibia. Yeah, I think we have been discussing, or the industry has been discussing this question for quite some time now. And I think the challenges are still the same challenges, really looking at navigating between different tools. And I think that is one of the main challenges that we faced. And I think one can just imagine if you're working with, say, 3 different vendors, that means you have to work with 3 different ICTs, ICT being the IED configuration tools. And really the issue will start when you start exchanging these files and importing CIDs in each other's ICTs, and that's where you're really going to face a lot of challenges. So one of the main challenges is different tools. You can have a system configuration tool neutral to any vendor, but still when you're done with modeling and configuring your system, you still have to export CIDs and import these CIDs into ICTs. And again, that's where you're going to face some challenges. So other challenges that I can think of are mixing of sample value profiles. Maybe say -9, -2 LEE with newer versions. You're going to see some mismatch and misalignment there. And also time synchronization, quite important, and mixing different protocol, time synchronization protocol, PTP and IRIG-B, for example, but also within the PTP itself. If you mix different profiles from PTP, you might again see a lot of challenges there. And I have an example from one of our projects that we actually, within the PTP profile, we mix the 2 profiles, the C 37.238 of 2011 with the 2017, and we couldn't get it work until we aligned the profiles. So I think those are some of the major challenges that we are still facing. There could be some other, but I think these are quite the major challenges that we are facing at the moment. Thank you.
Thank you, Franz, for sharing your insight on this topic. I fully agree with you. And regarding the time synchronization, yes, it's quite challenging topic in order to manage it well. We have an interesting presentation from Stephen from Siemens and the follow-up sessions where he will be talking about the time synchronization importance in digital substations a bit in detail. And let's move on to Komatsu. What's your take on the common obstacles faced during the implementation of digital substation? Komatsu.
Okay, good afternoon. Thank you for having me. My take is maybe there will be a few things. The first pertains to asset inventory. The foundation of cybersecurity is really knowing what you have, but in the world of operational technology, getting an accurate asset inventory is a massive pain point, if I can put it that way. We're not just talking about counting devices, we're talking about knowing the firmware versions, security vulnerabilities, and the lifecycle status of every intelligent electronic device, as well as the supporting network infrastructure. The problem is that without a full asset inventory, we cannot be compliant with cybersecurity frameworks such as IEC 62443 or others. We can't assess our own risk, identify outdated devices, or apply patches effectively. It's really like trying to protect a building without having its blueprint. The other challenge is that many older IEDs don't support the OT protocols we use for device management. An example being SNMP. We're sometimes forced to use OT protocols such as, and I think my MMS is just a newer one, but the older ones out there to just get basic visibility. So this lack of standardized management can make centralized inventory extremely difficult. When it comes to patching, which is something that is very commonly spoken of, when we're in the OT world, or should I say the OT world rather operates different when compared to its IT counterpart systems that are normally patched and rebooted frequently. When we come to OT systems, especially those in, say, substations, they are really designed for continuous and real-time operation. This makes patching a critical pain point. And we see that there is a conflict, there is a conflict between the IT's need for frequent patching and the OT's need for 24/7 uptime. Many of our industrial control systems are running on legacy systems that weren't designed with the modern security in mind. So applying a patch without proper testing could render the system non-operational with severe consequences. The risk is that without proper patch management, for instance, our systems are also vulnerable to the very known exploits that we are communicated with. This is especially true for some of our secondary plant equipment, which are sometimes coming from commercially off the shelves without built-in cybersecurity capabilities. But the solution somehow will be for us to be meticulous, and firmware updates must be pre-qualified and tested thoroughly in a lab environment before deployment. And then the other issue is with regards to remote access. Secure remote access is non-negotiable, but it is a continuous challenge. Getting remote access right will require us to address several interconnected pain points. We've got the security risk in the earlier remote systems where a major vulnerability was a major vulnerability, sometimes connecting the OT network directly to corporate network. You can just, I don't know if anyone can believe that. I think there are instances where a server sitting on the OT side was directly connected to a switch on the IT side. It's like bad interconnecting configuration. So the complexity is that managing remote access is a logistical nightmare. We have to deal with multiple vendor-specific software applications, each with its own requirements. We need a system that can manage all these different applications and provide a secure, granular access control for a multitude of users. Yeah, I think these are some of the issues.
Thank you, Komatsu, for sharing your insight on the cybersecurity aspect. because when it comes to challenges faced in digital substation, most of the points are coming from the cybersecurity aspect, because when you are passing data all the way, especially at the process level, things are digitized using sample values. And one of the critical requirement is to secure this communication between devices in the substation and beyond substation as well. And all the points that you shared are very well valid. And thanks for your insights. And next, I will move on to Diego. As you know, Diego, you're supporting many utilities across globe. Even you supported one of the utility in our region, especially in Ketraco in Kenya. And you know, most of the utilities, especially when they wanted to go from the transition from the conventional to digital substation, what are their main challenges that you come across, especially the project that you work with different utilities?
Thank you, Arul. I would say that one of the problems that utilities are facing is that when they start rolling out or building first 6150 projects, and especially digital substations, they realize that there is no further standardization for the implementations. They realize that there is a different story being told by the implementator and each substation. So you still use GUSes, sample values, reports as the standard defines, but each of them are created in a customized way, depending on the specific style of the engineer implementing the project. So it's of course interoperable. It's of course following 6150 rules, but each of them have different colors and flavors depending on who does the project. And that's one of the main challenges that utilities are facing. And some of them are already working on improving this situation by specifying better. And that's exactly the obstacle that we can realize. Utilities are not standardizing based on 6150. Most of the specifications are just complying with 6150, 6150 certification. And this is not bringing all the information for a real project. In a real project, you need more specific details. Otherwise, your projects will be a different story for each of them, especially if the company building the substation is a different company. So you will have a different story being told in each location. A second challenge, it's especially not technical even, it's the people. Many utilities, even when there are some enthusiast people looking to build digital substation, it's like him fighting against many others within the utility. The people is reluctant to change. And this is a big change for many people, for the technicians, for the protection engineers, or even for the automation people. They need to learn new skills. The utility need to train differently. They need to change well-established procedures or mechanism about training people, about maintenance programs. 6150 and digitalization bring a lot of benefits, but these benefits don't come for free. You still need to pay a price in terms of training people. But I fully believe it pays off at the end of the day, because when you learn 6150, you don't learn it for a single vendor, you learn the concepts, and you can apply the same concepts for all vendors, and you learn a language, the SCL language, and this language can be applied for all vendors in all kind of substation in whatever country. So then it's a learning curve, but it gets flat, and you get the benefit out of it when you invest on this training.
Thank you, Diego, and fully agree with you. Especially the utility should have the maximum control, making sure that, especially the point that you mentioned, specifying the required information at the very beginning of the project is so important. And I have seen also many utilities taking this specification before the tender, reviewing multiple times, and you also supported many utilities reviewing their specification, adding your comments. And there are some utilities I have seen and trying to set up interoperability testing, bringing the previously approved vendor for the conventional substation, and they ask a sample IDs and put together all of them and then make sure that all these IDs in a small setup works very well. This is what also we also got to know from Alex's presentation yesterday. Test and test, test, test. Unless you test and get to know whether things are working as expected, it will be a big problem later on. Good. We discussed about the common challenges which are faced in during the implementation of digital substation from the utility perspective, also from consultant perspective. Next, we'll move on to the practical solutions and best practices to overcome from these challenges. Komatsu, would you like to share your insight on the practical solution or best practices to overcome from the challenges that you talked about?
Okay, thank you. Some of the key main solutions is always implement cybersecurity by design when designing systems or even upgrading them. That then includes items such as accounts and remote operations. The core of a secure substation is identity and access. We have to move away from implicit trust and adopt perhaps a zero trust mindset. This means that every user and device must be verified and their access must be strictly controlled. The problem with the past is that we've all seen the shared admin passwords. This is a massive vulnerability that violates even the principles of accountability and opens the door for lateral attacks. So if we adopt a cybersecurity by design baseline, we then advocate for no shared credentials. Every user must have unique credentials, least privilege. We must implement role-based access control model. If a technician shouldn't have the same access as a supervisor, then that should be the case. This in a way follows a zero trust principle of giving users only access they absolutely need to carry out their functions. When coming to security, secure remote access, all remote access must be channeled through a jump server or host or a bastion host located in the industrial demilitarized zone. This creates a secure buffer zone to prevent any direct connection between the corporate network and our substation devices. When it comes to multi-factor authentication, this, like I said before, it should be non-negotiable for all remote access. I think it's the simplest and most effective way to protect against compromised credentials. Then another aspect that can help other than cybersecurity by design is whitelisting and network segmentation. In cybersecurity, the most effective strategy is to assume the network is already compromised. With that assumption, we then build layers of defense to contain any breach. This is the essence of defense in depth, and it's achieved through, for instance, whitelisting and network segmentation. The problem with blacklisting that we don't talk too much is simply blocking known bad traffic is almost a losing game. It's like trying to stop a flood by blocking one leak at a time. Attackers always one step ahead with this regard, so normally we don't talk about that. too much. And continuing with the server by design, we need application whitelisting. We must move from a blacklist to a whitelist, sometimes called a allow list approach. This means we explicitly define and permit only the commands and traffic that are absolutely necessary for the user's role. If a command isn't on the whitelist, it's denied. This is I think a much stronger security posture when coming to network segmentation. We have to logically separate our substation network using VLANs. This is OSI layer 2. This is critical. For instance, we need to isolate critical goods message traffic from engineering and management traffic. If one part of the network is compromised, the attacker can easily move to another. Coming back to the industrial demilitarized zone, this is a secure gateway between IT and OT. It really does act as a buffer zone, and it's meant to prevent any direct connection between the two zones, and that all data exchange and remote access must pass through this controlled environment, which prevents lateral movement for attackers. And I think we would have heard of IEC 62351. Also, as a baseline, we will need to enforce, say, goose and sample value filtering at the switch level. This is just to ensure that IEDs only receive specific streams they are subscribed to prevent malicious or compromised devices from flooding the network with unauthorized traffic. And then one last one, I think it's logging and monitoring. A secure system is not just about prevention, it's about visibility. If a breach occurs, we need a complete record of what happened, when, and who was involved. So a comprehensive logging and real monitoring are the key to situational awareness and effective incidents response. We need centralized logging so that all user activity, configuration changes, and system events must be logged and sent to a central server. This includes any successful and failed login attempts and every command issued. We will need a security information and event management solution where all these logs from various sources, firewalls, switches, IDs, can feed to this for just general monitoring and logging. Yeah, I think by implementing these controls, we can create a system that is transparent and auditable. We are not just hoping for the best. We are actively monitoring, detecting, and responding to threats in real time. And logging, by the way, I'm not saying each device must keep that logs. Those logs must move from that device because most of them are restricted. You can't really store data for that long. They override after some time. You find just after a month, all the logs are gone. Yes, thank you.
Thank you, Komatsu, and very insightful best practices which you discuss about in a few minutes time. You talked about a lot of things. I have some follow-up question on the points that you just covered. One of them is the role-based access management based on IEC 62351-8. In line with that question, do you think it's better, especially you talk about the default username and password, admin, and many other default password which we know very well. Do you think is it a good practice to manage central account management, like for example, connecting Active Directory, because whoever are going to work at the substation locally or remotely, especially the secure remote access, if the Active Directory account having the right roles and permissions to be able to access certain devices, it makes things easier, or do you have any other opinion not to have centralized account management, something different?
Yes, I personally strongly believe in using directory services, and Active Directory is one of them. It must not, and this Active Directory I'm talking about is private. It's unique to the OT environment. If you're sitting in a transmission environment, there lies an opportunity to centralize in that control center. Distribution, for instance, it might have several regions. You can still do centralized per region. If you have Active Directory, then you have the ability to take away this capability of people logging in with admin. You can remove it off every device, including the switches. That is one way of doing it. And I know the question of if it's centralized, what happens at the substation level? Should the link go down? There's other ways you can still deploy the same Active Directory, either fully fledged per substation, or you use, if it's Microsoft, you will use what they call as a read-only domain controller, which is just a read-only database for the substation. So everybody who's in that database will be able to go on with the business of administration. However, new ones won't come in until that link is brought in. So we can limit this password, for example, to the central location, to the select few administrators. The problem will still remain with them only instead of all of us.
Okay, thank you, Komatsu. Are there any standards from the international side or local standards from South Africa that you would like to recommend to follow the best practices, or from SIGRI on implementing the best practices on the OT cybersecurity aspect?
Yeah, I think there is a few we've been using. What we've been trying to do mostly is try to be more specific, and we've been looking at the IEC 62351 to see how can we better implement it. Although it's not too prescriptive, as some of the colleagues have mentioned, it needs to be tested. We need to test for ourselves and see what we can do. Just that I can't remember all the standards, but NEXIP also came up with good ones in the early 2000s before 62343 was published. So they all tend to try to achieve the same thing in a way. Yes, there's also for IEDs, I think there is a IEEE standard for minimum IED capabilities. So some of the protocols on newer IEDs are possible to be adopted. For instance, there's one called IEEE 1.x, I think port-based access controller. If an IED supports such a standard, it means you can also remove this default passwords from it. Then you centralize them somewhere else. So meaning everybody who must connect there will reside in some database, and then they can be managed versus currently what is happening.
Okay, thank you, Komatsu. Let's move on to Diego. Diego would like to share practical solution and some best practices implementing digital substation from your perspective.
Thank you, Rul. Yeah, I will try to summarize it shortly. So basically, we recommend to apply the same level of specifications as utilities used to have for a conventional substation. So if you remember, in a project building a substation, you have two choices: to build the substation with hard wires as your own style. So let's say the project company just do it following their own local design style and standards, or the utility have specific recommendations or requirements about how to build substations. I remember many cases where many details about the hard wires, the terminal blocks, the test block, many details of those were specifically defined by the utility. So when a maintenance guy goes to the substation, he knows exactly where to find most of the most common signals, because they were very well detailed by the utility. So they know that the test plug has a specific amount of pins. What is the meaning of the first pin or where the currents are? Even the vendor for the terminal blocks are from time to time specified for utilities. When we move to 6150, when we move to digital, some of these specifications are not beneficial anymore because we don't have terminal blocks, we don't have hard wires, but then the same level of standardization can be written in a machine readable language. You can specify those things in terms of SCL files. You can define how many gooses and how the gooses should be created. So you want to have, for instance, one goose specifically for testing. What should be the minimum content of this goose, and what should be the name of the VLAN and the application identifier for this specific testing procedure. So many of those details are just not considered by utilities. They just said, hey, just build it in 6150 style and then we'll be fine because we'll be following the standard. And it's true, it follows the standard, but doesn't follow your own specific requirements, and it will lead you to additional effort to maintain. If every substation is communicating the same data but in a different shape, then will be very hard to maintain. So the technicians have to deal with a different story, need to go to the specific documentation for every single substation because you have not defined anything at the beginning. Basically, you have just given all the freedom to build your substation. So that's the main recommendation to overcome those challenges. And the second is to centralize your engineering in 6150. Especially when you have multi-vendor applications, you have to deal, if you don't do a centralized configuration, you have to deal with multiple vendor tools. And then you do the configuration for one vendor in one tool, for the second vendor in a different tool, and then you have to start sharing files, and that will be very cumbersome, how to maintain the updated configuration, who has the last word, what is the last version. So if you do it central in a system configuration tool, even in a third-party system configuration tool, you can have centralized in a single source of information, in a unified language, all your configuration, and then you can transfer this centralized configuration to each ID configuration tool and download them to each vendor. But your single through of information is your centralized SCL file. And this SCL file will help you to do testing, to do maintenance, to even review the engineering during early stage of projects. So that's all the benefits that you can gain with specifying better and to support or to take benefits of what the SCL engineer or SCL configuration files brings to you. That will be a good summary.
Yeah, thank you, Diego. And especially I like the point regarding the harmonization of the substation levels. Like for example, of course, in the description you have the uniqueness, each different substation name and bay name and so on. But if you have a possibility to standardize from the substation till the bottom, like substation voltage level and bay level, ID naming, if you harmonize everything, it's easier even without going to the specific project, you can visualize things quite easily if you harmonize. And especially using the system configuration tool, it makes life easier. You just need to push the modification into the ID configuration tool once you've done all the data flow engineering. That's a very good, valid point. Thanks, Diego. Let's move on to France. France, you discussed about a lot of challenges, especially dealing with multi-vendor ID configuration tool, and then performing the data flow engineering to the specific ID configuration tools. What are the solutions or best practices that you come across to overcome these challenges, France, from your perspective?
Okay, thank you. I will try to be brief also. I think from our perspective, really is to standardize everything and also to follow the top-down approach. And I think Alex emphasized on this yesterday on his presentation. And from our perspective as a company here, as an utility, our philosophy is, this philosophy is also informed by one of the mistakes that we made on one of our projects. That when we went out in the market looking for vendors and system integrators, we did not really go in the details of the IC 61850 models and data structures and all this. It was left open, and in fact we had a very basic statement there that says that the projects need to be fully compliant to IC 61850 edition 2, but that is quite open to interpretation. And later on we spent a lot of time actually engaging the system integrator, try to make our requirements clear again, but actually in the end we end up taking that scope from the system integrator and actually do the work ourselves, because we couldn't agree on the requirements. But I think that is really what informed our philosophy of top-down approach and standardize everything from onset. But there are quite a number of other things that we need to put in place, like documents that need to be frozen before going out in the market, looking for system integrators or vendors. And some of those documents are name tagging and naming conventions. And again, I think Alex touched on that yesterday. We look at functional specifications. One need really to look at the detailed specifications of the project. And Komotso was also just talking about VLANs, and you have to make sure that you have your VLAN allocations documentation in place. Of course, you need to have your protection and control philosophies, and including your interlocking rules, because of course one of really the main reason for digital secondary system is to provide protection for substation equipment. And within this protection philosophy is where now you need to define all your signal flows, your sample values, flows, your goose movement within the network. So it's quite critical that you have those documents in place. And again, following the top-down approach, you have to have your SEL templates in place, going down to the basic applications profiles, details of logical nodes and data structures. You have to have your sample value profiles and goose profiles defined, and also looking at time synchronization, which is one of the critical things. How you have to define your PTP profile. And your grandmaster behavior, your holdover, and your failover strategy. And again, I think Alex yesterday talked about the crystals in the merging units, and that is really what we're talking about here, holdover. That once you lose your main time reference, your GNSS antenna, you need to your system need to still to have an accurate time, and your devices, whether it's a merging unit or clock, because the clock, they have those crystal as well, so that when you choose your clock, you need to make sure that it's provide enough time. Maybe it's an unmanned substations that you need to drive 500 kilometers. I'm coming from Namibia, we drive long distances. We can even drive 900 kilometers, and for you to get to the substation and maybe restore the antenna, you need to make sure that your clock can still provide accurate time to the requirements of sample value. And other things that we need to look at is test templates during FAT, interoperability testing, the SAT also. So with all your pass and fail criteria, and very, very important, it's the communication network topology. So you have to decide on the network topology. You have to design your network. Are you going to use PRP? Are you going to use HSR? So all this documentation really need to be in place. And also very, very important, you have to have this validated in a lab environment before even going out in the market, and before even deploying these systems on site. And also critical, you need to involve the teams, all different teams, whether it's a SCADA team, protection team, communication team, well in advance, so that you have alignment between different teams and all your requirements are actually in place. I think those are some of the best practice that really we can stick to when we deal with digital substation application.
Thank you, friends. Yes, it was really a good recommendation, especially using a top-down SL engineering approach, help you to save time when you move on to roll out many different digital substation projects, because you have a typicals, you can reuse those templates to save your time, and you can, of course, learn from every project. You can enhance the existing SSD file. And you can also improve some of the modification from the project that goes one by one from the lesson learned. Thank you so much for sharing your lesson learned and the best practices. Before I move on to the next topic, I wanted to remind the audience, please feel free to ask questions. You can also name Diego, Komatsu, France, and you can also ask question to them. I will pass your question at the end of the panel discussion. So feel free to ask any different challenges that you have come across implementing digital substations and the Q&A area. I'll be covering the Q&A after we complete 2 more topics. So let's move on to the topic 3. This is all about the innovative technologies in digital substation projects, meaning that it may be testing tools, monitoring solutions, which you feel it is good to have to be used at the beginning of the project and so on. Maybe I'll start with Diego. Would you like to recommend or propose some best practices in order to use innovative technologies in digital substations?
Yeah, thank you, Arul. I fully believe that the future is virtual. The future is virtualization. So nowadays, we have already in place centralized protections. That's really well known, I think, for the whole audience. But additionally, on top of that, there is a lot of efforts currently happening about virtualization. And I fully believe that there is no reason to not move in this direction. So why not to just bring a new server and remotely set up everything, including HMI, IDs, SCADA, even cybersecurity applications on it, and do it automatically, made by bots eventually, and automatically run test sequences to verify that the functionality is as expected. If we have all the technology already available, and the vendors are already providing those features in a virtualized environment, Omicron is also moving some of the tools to virtualization environments, because that's what have created a revolution in the IT environment. So we cannot imagine an IT world without virtualization. Everything currently it's using this technology because bring a lot of benefits. You can restore a system very quickly, and you can create more redundancy with those solutions. So there are many people who still concerns about the real-time performance of, let's say, server for real-time applications like protection. But this is already well known, and it's already supported by different hypervisor solutions, and you can already work on it. So we have already demonstrations, demo setups in Omicron available. So we have presented this in other events. It's possible to have real-time performance. It's possible to have multiple solutions running in parallel in a single server. And it's possible to get all the benefits what IT is doing in a substation. So protection will still run the same. So algorithms for protection, functionalities for gateway, protocol conversion, RTU functionalities, SCADA, all these features remain still in the same way, but now virtualized in a platform which can be easily interchanged, easily restored, and easily set up So if you can mount all your system in a couple of hours, it's definitely a huge improvement, and we can benefit out of it. But of course, as all new technologies had some reluctancy to be used, and that's exactly the goal of joining this kind of events, to promote this technology, to invite the people to try it out, to set up your lab. We in Omicron provide consultancy support for those kind of innovation projects. But yeah, it's happening already. There are substations running virtually already in different countries. So why not to try it out?
Yeah, thank you, Diego, for the insights. I think you, Diego, also part of the SIGRI working group, probably.
Not in the SIGRI specifically, but in the Virtual Alliance.
Virtual
Alliance. VPAC Alliance, related to testing. And
I see. Would you like to share some insight? What's going on there in the VPAC Alliance?
Yeah, the VPAC Alliance, it's grouping different players into the virtualization area, like vendors, utilities, and different people providing knowledge with the aim to provide a standard that fulfill their requirements, looking at what is available in the market and looking for the user necessities. That's why it is very important, and different players are part of it. And we are planning to release a document at the end of this year, which contains the different aspects, what need to be considered for virtualized environment in substations. So there are players from servers side, from testing platforms, from utilities, from IED vendors. So it's not about specifying something that only can be fulfilled by one player. It's about specifying something that benefit the energy community.
That's great, Diego. And how this document can be accessible? Is it through some?
It's still under definition, so because it's still a work in progress, but the official information can be found in the official website of the VPAC Alliance Group.
Okay, thanks, Diego. Now I'll move on to Franz. Franz, would you like to share some innovative technologies that you implemented in digital substation projects, like tools and technologies or the methods?
Yes. I think Diego was just talking about exciting things now, virtualization, centralized protection, and also yesterday we heard about digital twins from the presentations. I think those are some of the exciting things really that are happening in that space. But I want to also touch a bit on the synchrophaser and PMUs applications. And I was, I think the industry is doing quite a lot in that area, but I don't think we are there yet. And I think I was reading one article sometimes back. It's about the utilities in Mexico that have implemented quite a number of synchrophaser-based protection. And I think we really need to look into that space. I think most of the utilities today, they only use synchrophaser for system monitoring, for post-event analysis, oscillation detections, especially with now increased inverter-based resources. It's quite helpful, and I can testify that we have used that quite a lot here in Namibia. And it can really help in terms of detecting those oscillations mode, whether it's local modes, forced mode, or inter-area modes. And also mostly the applications of synchrophaser, we see them in island detection and decoupling, again promoted by decentralization of energy resources, and also generation and load management. Especially when you do islanding and decoupling, you also need to do your generation and load management. But in terms of protections, PMUs are still mostly limited to wide area protection schemes, such as out-of-step protection. But I think the industry is really putting more efforts into that space, and I think in the near future we'll see a lot of single phaser-based protection in substations. I think that's what I wanted to add to that so far. Yeah.
Thanks, Franz. I remember when I was a commissioning engineer 7-8 years ago, I have implemented many PMOs in the conventional substation. I mean, where there is no sample values, we've only used Goose for interlocks mainly, and the client-server communication for sending the report from the ID to the SCADA system. In most of the high voltage substations, where we wanted to implement PMUs, we had separate panels, and the hardware connection from CTVT all the way comes from the dedicated panel from the process level, and you have a separate GPS. It's too much complication having the setup. But in digital substation, having PMU makes things very easy, because you're going to use PTP, which is the existing time source available in the substation, and you can easily pass it via switches using transparent clock, and you have a sample values, and you can easily also subscribe the sample values without much complexity and compared to the conventional to digital substation. It's a big innovative idea. Thank you. And next, Komatsu, would you like to add some innovative technologies and solutions for digital substation projects?
Okay, maybe I must just start off with training, as I've also heard at the University of Bahrain that there is no shortcut to this. Yes, it is true, really. The shift to digital substations with their complex IC 61850 networks necessitates a profound change in the technical skills and behaviors. This is just not about just memorizing or cramming things. It's about trying to build a hands-on training platform that leverages modern computing principles, like it's been already mentioned, virtualization, and some of the open softwares to change the behavior on a fundamental level. The substation personnel really needs to also learn the advanced networking fundamentals, just moving from simple continuity checks to understanding the TCP/IP networks, and the same VLANs are still there, and also how to analyze packet captures with tools such as Wireshark. So where virtualization really can flourish or is very good, it's concerning the lab setups. The main thing that I think the utilities need to invest in is hardware platforms, so that these virtual labs can be run. The heart of this training model is we just need a hardware, and it should be well resourced with the CPU, RAM, and storage. Then we can run powerful hypervisors that are even open source, such as your Linux type. The network gear, you need the lab. The lab must have its own dedicated network infrastructure to include your managed layer 2, 3 switches and routers. This then will allow one to simulate real-world scenarios involving network segmentation, routing issues, firewall configurations. I mean, just example with the firewall. Exactly the same firewall you have can run on this platform. You take exactly the same image and it runs there, to a point where I thought that was digital twins. So I think virtualization and open source tools can play a big role, and networking emulation platforms out there. There's many, some are paid for, but if you are trained, some of them are just good, just like Wireshark. For example, I know of Graphical Network Simulator 3 or GNS3. You can really run real device images on that platform. The difference is they are resource intensive. If your firewall wants 8 gig, it will require 8 gig in there. So your hardware platform needs to be
well resourced. And I did hear Diego talking about testing that can be done using virtualization. Yes, automated testing can be done within a virtualized environment. We can create automated and repeatable test procedures. And the good thing is, if you're using, say, VMs, when you back up a VM, it's just the same VM. You can take the same VM from production, put it in a lab environment. It's exactly the same one. The only difference is there will be no production issues. So you could even work on it, upgrade it. Maybe you want it to be patched, for instance, or upgraded. You can do that there. And if it fails, you know, or document the exact procedures that must be done on production, or should there be an outage, you take the very same one that was upgraded and swap it with the other one that is there. Basically the same thing. But what I've wanted to talk about also is the issue of, because I heard the PMUs being spoken of, and the amount of data they consume. One key thing we don't talk about is the value of a data historian. You know, it is a specialized high-performance database that is designed to collect, store, and manage vast quantities of time series data. So as much as the PMUs consume, your SVs, GOOS consumes a lot of data. That is the one solution that can historize all that data. It will consume GOOS, SV, and PMUs. I suppose they consume a lot of gigabytes instead of megabytes. But if you have resourceful hardwares, you can store this data for a long time. I mean, currently, analog data are being stored in certain plants. So even if you move to SV, that's analog data. They need to be stored, and we need to historize them and be able to compare maybe devices over time. So I think historian and this open source ones, classic one that is out there that claims to be able to historize PMU data is Open Historian 2. That one is freely available. You just need hardware to test it. Then the ability to, we need to be able to see our plants regularly. I normally repeat this to say it is quite strange that the operator is able to tell any given time the status of a circuit breaker. Is it open or closed? And yet the network person who deals with the routers, switches, is unable to see what is happening inside a switch, what's happening with the MAC addresses, what's happening with the routing table. It's a bit strange, because if the operator can see the circuit breaker, they should be able to have been able to see their networking infrastructure using the very same equipment. So visibility is very important, and as Diego said, these solutions are already there.
Yeah, thank you, Komatsu, for sharing your insights. We have one last topic. It's all about future trends and developments in digital substations. Let's start with France quickly. We have just 5 minutes left. You can briefly talk about the future trends and development in Nampower, like a rollout for large-scale digital substations, something like that.
Yeah, okay. I think the future, especially when we're talking about virtualizations and digital twins and cloud-based protection again, it involves a lot of data, and we have to have some sort of procedures and maybe contractual agreements between OEMs and utilities in place to be able to manage and share this data. And really, digital substations are main. They produce a lot of data, and we can make use of this data for other applications. Like from the utility standpoint of view, you can use this data for predictive maintenance. You can feed this data into your data analytic tools, AI-based analytic tools for informed decision making. You can also have some sort of arrangements between utilities and market operators. Especially now we're talking of markets that are evolving, especially here in Namibia. We are implementing what we call a modified single buyer model, where IPPs or independent power producers can actually set up their own power stations and have bilateral transactions between IPPs and consumers without really involving the utility. So, and that will actually encourage sharing of data between now different entities and with the market operators and with the regulator as well. Other areas that I see a lot of developments in the future will be again promoted by renewable energy, where we have bi-directional flows of power because of renewable energy. We'll have to have adaptive protection in place that will actually dynamically change settings and logics based on the flows and the system configurations. We have to look at DR models for seamless integrations and control. And also, we're just talking about synchrophaser. We have to bring in synchrophaser into our protection. So, and centralized protection, of course, is one of them. And Alex yesterday again gave a good presentations on centralized busbar protection, and I think those are some of the future trends that we see, and I think, yes, we need to take opportunities and really push for that.
Thanks, Franz. It was really a good opinion in terms of the future trends that you shared. Komatsu, would you like to share some opinion? Just take 1 or 2 minutes, because we have to take some questions as well.
Okay, yes, I think what will happen is in the future, probably still happening, we'll see standardizing engineering and data models. As Franz mentioned earlier, the future will see maybe a more top-down engineering approach for all IEC 61850 projects. There will be stricter rules for IT/OT convergence and remote access. As the attack surface expands, regulations will then enforce secure layered architectures. The Purdue model and its alternatives, with its dedicated industrial demilitarized zone, will become a foundational regulatory requirement, along with standards such as IEC 62443 and IEC 62351. And we also see stricter rules for remote access, mandating the use of jump servers and privileged access management systems to enforce concepts such as zero trust. We will have enhanced asset management and documentation with digital twins and virtualization. I think regulators will require accurate digital asset inventories. These regulations will probably demand a list of assets, but also a complete, accurate record of their hardware, firmware versions, and patch status. Yeah, I think I'll leave it there.
Yeah, thank you, Komatsu. We have just 2 minutes left. Before I move on to Diego, when you wanted to address the future trends in digital substations, Diego, and you can also address this question. We have a lot of questions in the Q&A, but we have limited time, but we will share the questions and we will definitely answer all the questions later. I'll pick one question to you, Diego. It's from Resham Singh, probably from South Africa, working in Tikwani City. It is an interesting question. IEC 61850 was deliberately designed to be flexible, but flexibility leads to a non-standard implementation, which creates interoperability, maintenance, and integration challenges for utilities. Is there any best practice, engineering handbook, or technical report that utility can use for guidance in IEC 61850 implementation, Diego?
Thank you. I think there are good material from SIGRE, especially
Yeah.
about recommendation on using 6150 or digital substations. That's about how to use sample values, how to monitor the functionalities, how to use BTP, even or some recommendations about networking. But still the topic remains. It's true, 6150, it's designed to be flexible, to allow vendors and utilities to develop. If the standard were so narrow, then everybody has to do exactly the same. There is no room for improvements. That's exactly what the standard tries to avoid. Give room for new development, and the vendors can develop something new and can shine in the market, so that you have the option to choose the best option from the market. But it doesn't mean that you have to bring all this freedom to your substation. You can still define what are your preference. You can pick the best of the best and then specify them to your own implementation or to your utility. And then you get benefits, but not the same benefits are applicable for everybody. For instance, in distribution, we see that the requirements might be quite different from transmission. So also depends of the level of standardization that you want to put in place. So Komatsu and Fran has already mentioned, standardization is the trend, and I fully agree. So I see every day more projects than utilities want to standardize the engineering, standardize the configuration, and of course, standardize the testing templates. And then you will benefit a lot of 6150. So I don't see flexibility or as a disadvantage. Against, I see this as an opportunity to pick the best out of it.
Thanks, Diego. And we got a lot of questions, by the way, and we have no time because we have follow-up sessions. But definitely to all the audience, we will address all your questions. I will be sharing the questions with the panelists, and we will come back to you by email. And with that, I would like to thank you, everyone, especially the panelists, Diego, Komatsu, and Franz, taking your time and sharing your experience and insights, best practices about implementing digital substation projects. Now I will move on to Marwa.
Thank you to our
Thank
moderator,
you.
Engineer Arul, and to all of our participants, Engineer Diego, Franz, and Komatsu. We'll now move to our next technical session, the practical implementations of the digital substation concept, presented by Engineer Yassine Aguzul from GE. Engineer Yassine, over to you.
Thank you, Marwa. So I'll just start sharing my screen. I hope you can see my screen so far.
Yes.
No, I believe I need to. Second, I need to switch to the other one.
Sure.
Yeah. Can you confirm that screen is visible with the presentation?
Yes, it is.
Yeah, okay. So first, I would like to thank you, Marwa. Thank you, Arul. Thank you, all the participants in this tremendous event. It's really interesting to have these expert talks and everything. In my session here, it will be like more of an ROE and expertise change, or let's say experience exchange with the audience from the practical case we had in the region, since we had the chance to execute the first digital substation in the region in this year, during this year. So to start, this is will be the agenda of today. So we will start by a small description or a small comparison between the digital and conventional substation. Followed by the IED application for any acquisition. You know, when it comes to merging unit or SCU or PIU, would like to highlight or stress on that one. What is MU? What is an SCU? What is PIU based on the standard classification? After that, we will see a detailed view of the digital substation bay and how it is compared with a conventional bay. Later on, we will see the time synchronization and how it is important to be used in a digital substation, and how this time sync or time synchronization issues can delay or can create a mal-operation in a protection relay because of the wrong measurement or the wrong quantity received in the wrong time. And finally, the 2 points that are most of the ROE from the actual case or from the actual substation we are executing is the protection scheme testing and the importance of using the VLAN in a network. So here initially, I would start by this slide where you can see a digital substation versus the conventional application. We all know that this is something more and more now known and more and more familiar for every engineers, for most of the engineers in nowadays compared to the past 5 years or 10 years when the concept was still new. But I would like to highlight on it just because using or seeing a practical case of a digital substation is really important, and you would see the difference exactly when it comes to the cost optimization, the footprint of the substation, the number of fibers and number of copper wires that are used. It is really important to see this in the practical case. As you know, the most of the data in the conventional substation will be over copper from the switchyard or from the switchgear or whatever the case up to the control room or to the relay room. Whatever, the moment you are using a digital substation or you are into the digital concept, most of your data is available into the network, and it is acquired only one time, and it can be accessed from multiple points, from multiple devices at the same time with almost no limitations. Further on, you have the normal access, or what we call the station bus, the normal level that will be managed after that from the substation itself or from all the acquired data at the relay rooms to the substation automation system in the substation. So here are the different appliance, or let's say the different application. So whenever an IED is just taking care of converting the analog data or the analog quantities of CTs and VTs measurements into digital values and later on be published or streamed onto the process bus, this is what exactly we call a merging unit, since it is managing only the analog quantities. The other option or the other application is to have just the binary signals. So when we are talking about binary signals, we are talking about the status of the breakers, isolators, the commands to the isolators and breakers, and so on. So when a device or when an IED is managing only the IOs, it is called, or it is known as the switchgear control unit, or the SCU. And then we have finally what we call the PIU, or the process interface unit. So in this case, it will be nothing but a combination between the merging unit application and the SCU application in one box or in one IED. So here in this slide, we would like to compare when it comes to a conventional bay protection and control. Okay, when it comes to the assignment or to the wiring from the different core that we are using in the feeder, with the conventional substation, we all know that in specific cases or in the most of the cases, we are using a separate core for a separate IED. We are using independent tripping path and closing path for every device when it is a main one, main two devices, as well as sometimes if it is a BCU or a bay control unit. However, if we move, or if we'd like to move into the digital bay protection or into the digital bay example, you can see here that this limitation of number of cores is not there anymore. So unless the customer is not using separate cores by any standardization or by any requirement, we can still use a single core. This single core can be wired to the first MU, for example, or to the first process interface unit. And from that point, all this data acquired one time can be published into the network and made available for different devices. Either it's a main one, main two, a BCU, or even a different bay when it comes to complicated application like the bus bar protection, the CB fail, or even the synchro check when it comes to the VT sync or to the bus VT or the bus voltage for sync check and reference voltage application. So here we can see the advantages coming in the number of cores. So which means exactly that you can still reduce the size of CTs with less cores. You can have additional cores that can be there as a spare, which is not much the case when it comes to the conventional, where most of the cores are just like fit into the requirement or to the number of the device used. So in the same idea or in the same point, you have also for the binary statuses. So when it comes to inputs and outputs, the same information can be acquired one time by a device. Either it's a SCU, PIU, or MU, depending on the application and on the use case. And this acquired data is also made available in the network through the process bus for the different devices and for the different use cases, and can be exchanged between feeders even if it is required for some specific or special scheme requirement. What is important here to mention is that when it comes to the digital substation, the clock or the time synchronization is something really, really important. So in the protection scheme, if we have a time delay between the acquired data from the MU and what is really happening on the network, this might cause a very serious conditions. So this is what we will discuss here in this slide. As you can see here, from a source voltage, if the delay between the acquired data and to the published data to the protection relays is less, or let's say 1 millisecond, this will automatically create a phase shift in the acquired analog values or in the sampled values published into the network for almost 20 degrees in the angles. So this differences, if it is not managed correctly, this will create for sure unwanted operation and maloperations in the protection schemes. You can see here in another example for a current circuit, if the angle is or if the time delay is 2.5 milliseconds, the difference is like 50 degree compared to original data acquired from the network. That's why it is important to stress on the time sync. It is important to stress that the moment we are using sampled values and we are acquiring the data from the immersion units and publish into the network, we mostly use the PTP, which is the most accurate protocol known so far. And one more thing is important, that instead of just the time sync, or in addition to just the time sync, it is also important to take into consideration the different delays that are available in the bay. So starting by the MU processing delay, every device will have a processing time to acquire the analog values, to generate the conversion, or to manage the conversion up to the sample value streams or the digitized value before starting publishing these values into the network. And this for sure will be having a delay that needs to be taken into consideration. After that, the moment your SVs are published into the network, we should also take into consideration the network or the delay in the network. So with every hop from a switch or with every layer from a switch, it can add 2 to 3 millisecond delay into the data acquired or the data received by the protection relays. So fortunately, this is taken care by different devices or by the devices in different way. So there are some protection relays where you will find an option to mitigate the MU processing delay before, or like knowing what is doing a test or practically testing the MU processing delay and having this time as a setting to be setted or to be recorded in the relay, so it will be taken into consideration at any moment the relay is receiving the data. In another way, there are different relays that are doing a time alignment based on the timestamp, based on the received SV and the received timestamp from the immersion unit itself. So after the timestamp, I would like here to show one example of the protection scheme testing that we've had in the practical case. So in this case, we were using the Station Scout solution from Omicron and the MBX2 as a hardware. So first, we were able to like duplicate, or let's say double confirm our configuration, what is ever done or what is ever implemented in the substation in the different devices by the SCD file. The moment we open the SCD file in the Station Scout, you can easily see and track what is publishing what and who's publishing to who and who's subscribing to what stream or what frame. You can see the different signals here from the left corner, from the light top corner. You can see the goose signal, you can see the SVs, you can see the reporting links between the different IEDs up to the SAS system or up to the other IEC clients. So it is really important to have this tool during the commissioning phase, because it will like reduce the time testing or reduce the testing time for sure, because in one click you will be able to explore all the links and all the capabilities and based on your actual configuration. The good thing is that you have the two options. Either you can check the configuration offline before starting the tests, or you can go in the online mode. So the moment you are in the online mode, you have the options like to see whoever is connected into the network, define the configuration or define the GOOS messaging and the SV publishing and subscribing between the different devices and different MUs and BCUs and BCPUs even based on your application. The advantage of the tool is that it will give you different alarms based on the statuses. Like you can see here, some of the IEDs were having a yellow or exclamation mark, where after investigation, we could see that some of the publishers to this device are absent from the network, or some of the subscribers are having different CID version compared to what we are running due to some modification or some recent modification done after we have acquired the SCD file. In this next slide, so I would like to highlight also the importance of using the VLANs. So as we all know, every emerging unit will publish the sampled values in a different stream that is based on the protection or on the measurement application. So if it is a protection as per the standard, we are talking about 80 sample per cycle. So we are talking at least 3.2 Mbps, and this quantity is different than in the conventional substation, or let's say in a numerical substation, because in the moment you are using the SVs or the MU will continue and continuously publish the streams, whether or not there is a measurement, whether or whether or not there is a fault in the line, whether or whether or not there is a quantities in the line. So even the values required or recorded by the MUs will continuously be published based on the selected sampling rate. So with this said, we all know that most of the IEDs so far are having 100 Mbps ports only. So if we miss in the design, or if we have a design with the network based on 100 Mbps only, this for sure will create a huge issue when it comes to the network communication. These high frames or these big size frames will create high traffic and will have a lot of issues in the network, up to, or that can reach up to even the network backbone crashing or stuck. So the first consideration, or the most important consideration to be taken here, is at least your backbone for the network should be, or for the switches should be with 1 GB per second. So after that, the use of VLANing will be useful, or will be very important, because using the VLAN, as you all know, we can reroute the data from different port to another, from a different host to a subscriber, to a publisher, and giving you the capability to manage correctly the traffic in the network and less stressing on the network switches. So one important, or one information I'd like to share, is that the moment we compare between, let's say, a process bus network or a network in a digital substation with a network in a conventional substation, or let's say numerical substation with non-digital or with no MUs implemented, we can easily see that in the other cases, or in the non-digital substation, we are using a network traffic up to less than 20%. So if we are designing in 100 Mbps, we are talking about at least 20 Mbps being used. However, the moment we are using the VLANs, or the moment, sorry, we are using the sampling values or the sample value streams, the quantity of the traffic is getting higher and higher. And this, of course, can be tested aside by different cases or different simulator, where you can see or stress the network switch and see what is the available, let's say, bandwidth still in your network, or what is the free bandwidth available in your network. And just to make sure you are not using the switches, the network switch, as a capability more than 80% of the capability of the switches itself. So quickly back to the conclusion. So I would like to mention here that having a digital substation, for sure, is the future, and it is a cost-saving solution when it comes to the design, when it comes to the footprint of the substation, the number of panels, and so on. However, it is really important for engineers, or especially for protection engineers, to follow the technology, and also to be, let's say, modern protection engineers, because the moment you are just stuck with the protection testing, the injection and distance and protection functions alone, you will not be able to manage, or you will not be able, let's say, to survive in a digital substation. A digital substation will require different aspect or different assets of skills, when it comes to the communication protocol, the media linking, the VLANing, the MAC address filtering, and as what mentioned also in the previous session, the knowledge and exposure to network and network configuration should be there. The capability or the willingness to go and dive deeper in these kind of concepts is really, really important, because this will be very helpful when it comes to investigating, when it comes to double checking or doing the tests at the substation with the digital concepts. It's really important to know how to diagnose, how to use the Wireshark, how to use the sniffers and different other tools from Omicron or from other solutions. And with that, this is the end of my session. I'm available for any questions.
We have a lot of questions, Yasin. Thank you for that.
Yeah, for sure.
Quick introduction on the digital substation implementation. Let me start with a question from Hussein Kadam, and Zain Ali also has a similar question. Can all existing substations can be digitalized, and what are the challenges in doing so? Also, what is the impact in reducing the energy consumption in digital substations?
See, I would start by the reducing the energy consumption. Okay, so the moment we are moving into more and more digital, we all know that the chargers and the additional batteries will have a huge impact, and this will be for sure reduced. The amount of energy consumed by the electromechanical relay, or let's say just the numerical relay, and the additional auxiliary relay we are using a panel will be hugely reduced. So far in our practical case, we reached to the point that we would be able to, let's say, migrate or combine two feeders in one panel, including the main one and main two relays, just because there was literally no auxiliary relays in the protection panel. There was less wiring in the protection panels, and for sure this will have impact on the design of the consumed energy in the substation. The other question related to, let's say, digitizing existing substation. I would say this is still possible, because you can still use the conventional CTs and VTs, just introduce the merging units at the LCC panels or at the GIS building, whatever the case is, and wire these data to the MUs. The challenge you might face is that the existing network in most of the conventional substation, our design in the network is less than 100 Mbps, or let's say 100 Mbps, because we are not using much of bandwidth when it comes to just goose communication or normal goose communication and reporting between the devices to the servers and clients in the gateway and the substation itself. So this will be like, let's say, the most challenging part, but as a possibility, it's there and it can be done.
Okay, thank you, Yasin. And I'll go for the next question from Zuko. In digital substation, do consider failure on one CT or failure on a PAU. As part of the redundancy in the design, is that alternate solution to overcome from these failures?
Yeah, so in this concept, we are using always the redundancy. So when it comes to the merging units, the use case we are having is that, like, first core from the CT is connected to the first MU. Then you have the second core from the CT is connected to a second MU. So obviously, this is having a redundancy when it comes to CT cores, and having a redundancy when it comes to merging unit as devices or as IEDs. After all, or after that point, you will have these two MUs. Every one or every MU will be sent to set one relay and set two relay as a backup in case of failure in the CT core or in the MU itself. So redundancy can, let's say, very easily be achieved in a digital substation. Yeah.
Yeah, thank you, Yasin. And let me go for the next question. This is from Suresh Natarajan. With more and more upcoming digital substation and transmission, how are we looking at the adaptation of digital substation in primary distribution and secondary distribution networks?
I'm not sure if I'm getting the question correctly. I believe the question is related to using a digital substation or implementing the digital substation concept in distribution network, right?
Yes.
Yeah, so even in the distribution network, this will be still possible. Okay, the use case will be that in some substations you might have the let's say the distribution switchgear or the MV to LV part is conventional. However, the moment you can use the merging units, you can redesign your substation, you can redesign your footprint of the substation, and this will be very much important. And moreover, the moment you have your data acquired and available in the network, this will give you more flexibility and more availability compared to the conventional, where you need the wiring for every specific devices and different application.
Yeah, thank you, Yasin. And we have more questions.
Sure, no issue.
Okay, I'll take the question from Jimmy. How will merging units and non-conventional instrument transformer be physically implemented, and what are the environmental protections will be necessary for their field installation? I mean, he's talking about a different environmental condition, not just in Middle East, because most of the Middle East we have GIS, everything is in good environment, but outside when we compare with AIS, yeah.
Yes, in outside cases or in AIS substation, what we are proposing is that the MUs should be implemented in, let's say, a much sophisticated cabinet. I would call it so. That cabinet itself will be double foamed or double-sided metal enclosure, and will be protected with foam for the protection from heat and from different, let's say, environment condition. But as a use case, it is possible, and it is being done even in different countries. So it can be installed outside with additional protection for sure.
Okay, thank you. And I'll move on to the next question. Okay, this is from Rami Assam. Did you commission any complete digital substation in the Middle East? Which country?
Yeah, so far this is the ROE I am sharing here. So we are like in the last stages of the commissioning of our first digital substation in the region. It's in Saudi Arabia, and that's it.
Okay, thank you. And there's one question specific to GE. How far has GE progressed with the optical CTs? I think there are optical CTs from GE.
Yeah, there were optical CTs, and there was one factory back in Italy, but there was some restrictions and some movements from the GE to GE Vernova and so on. They are experiencing some difficulties, but the factory is still there, and it might restart again in Zodiac. Yeah.
Okay, thank you. Does the digital substation implemented entirely the use of digital twins? Is it possible
Again, sorry?
to implement? Is it possible to implement a digital substation in digital twin? There's a question from Zuko. You know about the digital twin, right? Hosting the ID on a cloud, for example. And is it possible to completely simulate the digital substation in digital twin platform?
I'm not sure if I can answer that one, but I can take it for later, Rule, no issue.
Okay, thank you. Okay, can you share your view on the maintenance requirements of the digital substation? This is from Magetle.
Yeah, so when it comes to maintenance, it is really important. That's why I have stressed out in the, let's say in the last slide about modern protection engineers. So when it comes to the testing or to the maintenance part itself, at that time, we need to have a huge or let's say a complete understanding of the different modes, and especially the different test modes between the IEDs, the MUs. Otherwise, it will be difficult for us to do any maintenance operations. But the moment you know what is the different modes, how to enable every mode, how to protect yourself from the mal-operation, how to block or how to be in that correct bubble between, let's say, the IED. I would give an example. If my IED is in a test mode, but the MU is not in the test mode, for sure the test will not happen correctly. However, if I am going as per the standard and the MU as well as the relay, both are in the test mode. You have inside the test mode, you have also other sub test mode. We can tell like test blocked or just test or simulation mode. You need to go with the correct part before you will be able to simulate. But in general, it will be simulation, or it will be the maintenance will be very easy in this case. The testing will be very easy. You have, let's say, a lot of tools or a lot of options to simulate these kind of fault or of SVs or signals, and you will not acquire or you not require much of preparation for the testing. Let's say it's all virtual and it's all can be managed. Yeah.
Thank you, Yasin. And I'll take one question. This is the last one. And remaining question,
Okay.
we'll address it by email.
Sure.
Do you recommend the utilities consider specifying protection relays with built-in merging unit functionality?
As a recommendation, I would not see the importance of having a protection relay with the built-in let's say sample value streaming or publishing case, because in all the application you will need to acquire the data and then publish it to devices that can manage. So better to not stress out, or better to not overload your device or your IED when it comes to its own CPU capability, its own, let's say, hardware capability. Better not stressing it out with all the actions. I would prefer to have the MU separately and the protection relay separately. So even in case of a failure, at least I can the modification or the correction will be less complicated.
Okay, thank you, Yasin, for addressing all the question and a nice presentation.
Thank you. Thank you.
And I will move on to Marwa.
Oh, sure. Thank you.
Engineer Yasin, and thank you, Engineer Arul, for moderating. Now we move to the final session of the day. Please welcome to the stage Engineer Stefan Fleming from Siemens for his session Time and Sample Synchronization in an IEC 61850 digital substation. Engineer Stefan, the floor is yours. Engineer Stefan, can you hear us? We apologize for the technical difficulty. Engineer Stefan, can you hear me? We apologize again for that. It seems Engineer Stefan is having difficulties with his microphone. Maybe in the meantime, Engineer Arul, you can take a question from the pending questions.
Okay, sure. Thank you. Good that Yasin is already available here. Meantime, before we get Stefan in. Okay. Okay. Yasin, are you there? Hello? Hello, Yasin.
Engineer Errol, maybe you just read the comments that were coming through, and if you have anything to add to them or answer any questions yourself, that would be great as we
Okay,
connect with Engineer Stefan again. We apologize again for this
sure, no problem.
technical
There's a question
difficulty.
from Kevin. The question is, how long will it take to fully digitize a substation? Taking in knowledge is, okay, I think Stephen is back. Stephen, you can unmute and try your audio.
Hello, everyone. I'm audible now?
Yes, very good.
Okay, so now we managed. So, okay. Sorry for the technical difficulties here. Let me share my screen. So my screen should be visible now. Okay, so let's start. Warm welcome from my side. My name is Stefan Fleming, and I'm a product lifecycle manager at Siemens. And it's an honor for me to talk to you today about the challenges and solutions for time synchronization in the digital substation, which is crucial for maintaining system stability and avoiding protection blocking. So let's start with the most common architecture for time synchronization in a digital substation. Typically, we see a hierarchical structure from the station level with a connection to the control center over a field level, with protection devices to the process level, where the merging units connected. All interconnected via a redundant GNSS-supported IEEE 1588 Grandmaster clocks distributing the precision time protocol. This approach offers redundancy and ensures date and time information is available throughout the network. However, it's not without challenges. The stability of a PTP time base is crucial, what we have learned also in the panel discussion. Any instability, often due to GNSS signal degradation, jamming, or spoofing, can lead to protection blocking. Addressing this vulnerability is a key focus for modern substation designs. So before we go further, I like to focus on the synchronization of sampled values. So let's look at how synchronization information is embedded in the sampled value telegrams. And 6150 edition 2.1 SV stream includes sample count, which counts from 0 to a maximum sample per second, for example, 4,800, and resets to 0 each second. The sample synchronization information indicating the reference of a sampled value is E for global in case a GNSS traceable time base is used, local if a local clock is the reference, or none if the internal oscillator of a merge unit is the reference. In case of IC 6150 edition 2.1 compliant merge unit, a third information is available, the synchronization source identity, also known as the Grandmaster identity. This information indicates the unique MAC address of a PTP Grandmaster used to synchronize the sampled values. These fields enable devices to accurately interpret the time base and maintain synchronization, which is crucial for advanced protection functions. Notable is also that there's not an absolute timestamp used. The timestamps are all relative to the sample sync reference. Let's spend a moment on why protection in process bus systems gets blocked by time synchronization events. The root cause are changes in the time base. Specifically, jumps exceeding the required accuracy of 1 microsecond means T5 or 4 microseconds for T4. Such jumps force a resynchronization of sampled values with consequently temporarily blocking of the protection functions. These jumps are typically triggered by loss and return of GNSS signals or by intentional interferences. Let us go through the process of losing GNSS signal and the consequences for the protection. When the GNSS signal is lost, the Grandmaster clock relies on its internal oscillator to maintain accuracy. The clock class changes from 6, means GNSS synchronized, to 7, holdover mode, indicating the system is now relying on the internal oscillator of a grandmaster clock. The duration for which the oscillator can maintain the required accuracy depends on its quality. Atomic oscillators can hold for multiple hours or even days, while quartz oscillators may only last minutes. Once the oscillator can no longer maintain the required accuracy, the clock class degrades below 7. At this point, the sample synchronization information in the sampled value stream changes from 2, meaning global, to 1 for local. A state-of-the-art 6150 9-2 edition 2.1 system withstands this state, how I will explain in a minute. Otherwise, the protection blocking can occur even in this local synchronization state. When the GNS signal returns, a jump in the time base happens because the internal clock of a merging unit adjusts to the now again available global time base. The merging units resynchronize and publish the sampled values with sample sync 0, meaning none during this process, which consequently leads to protection blocking until the synchronization is restored. And sample sync global is being sent again. This sequence highlights the importance of robust time synchronization and the ability of protection devices to evaluate synchronization sources for the case of local synchronization. In summary, preventing protection blocking means also avoiding jumps in the time base. So as we have just learned, there are 2 critical states that can lead to protection blocking. Number 1, when the PTP synchronization loses its GNS connection, and number 2, after the return of the GNS signal. To mitigate the first one, where sample values are indicated with sample sync as local, it is without additional measures impossible to align the samples because there's no guarantee that the synchronization source is the same and that the samples are thus aligned. The solution to this is to insist on the use of GM identity to uniquely identify the PTP synchronization source. This means that the merging units must be able to publish their sampled value streams with the grandmaster identity, and that the protection device must have the ability to evaluate this information. In such a system, the measurements from the various sampled value streams are declared synchronized if sample sync is global, which is obvious. And if the grandmaster identity for local synchronized sampled values is the same, thus proves the same PTP synchronization source is used for synchronization. Since the duration of local synchronization state is usually longer than the resynchronization state of the sampled value stream, after the return of a GNS, a big step towards a more reliable digital substation is taken using a 6150 edition 2.1 compliant devices. So to mitigate the time jumps caused by return of the GNS signal, we have to first understand the diverse requirements for time synchronization across substation applications. Let me walk you through the table shown on this slide. What applications require a time synchronization? We have first of all event and fault logs as well as the fault records. So here the accuracy requirement is 1 millisecond, less stringent, but still critical for diagnostics and event reconstructions. These logs rely on absolute time and can be synchronized using IEEE 1588, IRB, NTP, or SCADA protocols. Another application are phasor measurement units, respectively wide area monitoring systems. These systems require absolute timestamps for precise event correlation across wide areas with accuracy requirements of plus minus 26 microseconds for 60 Hertz networks and plus minus 31 microseconds for 50 Hertz power systems. The synchronization methods here could be EVPTP or IRB. And finally, the synchronization of process bus, meaning sampled values. This requires extremely high accuracy of 1 to 4 microseconds, and the relative time reference is in contrast to the other applications sufficient, as the goal is to align signals within the system. Synchronization is typically achieved via PTP, IRB, or in the older days also PPS. As a key takeaway, I would say time synchronization is not a one-size-fits-all solution. Each application has distinct accuracy and time reference needs, which directly influences the choice of synchronization method. Understanding these differences is essential for designing reliable, efficient, and cost-effective substations. So let us have a look how jumps in the time base can be avoided. There are certain solutions available and can be used. So one robust solution is the centralized PTP distribution over the enterprise network. By investing in hardened clocks, often equipped with atomic oscillators as a primary time source, we can mitigate time drift during GNS outages or manipulation, and also jamming and spoofing can easily be detected. Centralized distribution limits the risk of unstable PTP time bases and protection blocking. The enterprise backbone provides a resilience against jamming and spoofing, ensuring stable synchronization across the station and Postbus networks. For redundancy purpose, in case the connection to the enterprise network fails, at least one PTP Grandmaster clock should be considered. This clock must be coordinated using the priority 1 setting to ensure that this Grandmaster clock only takes over in case the Grandmaster clock from the enterprise network is not available. However, this approach requires significant investment in the infrastructure for distributing the PTP signal throughout the enterprise network. This investment in hard clocks and network architecture is justified by the increased reliability and security. An alternative approach is to use free-running Grandmaster clocks for the synchronization of samples. So these operate as ordinary clocks, ensuring a steady relative time base and also allowing also an enhanced cybersecurity by isolation of a Postbus network from the station bus network. Because of a missing GNS reception, this method is immune to GNS jamming and spoofing, which maintains a stable PTP time base for the sample synchronization and thus avoids protection blocking. Important, this architecture relies on the separation of date and time synchronization from the sample synchronization. This specialization of synchronization for the various applications, which require a global reference or not, allows the sample synchronization to decouple from GNS. So the synchronization of sampled values relies on a stable relative time base within the Postbus network, independent of any global time sources influences. The synchronization of applications requiring date and time is managed separately, using, for example, SMTP Time Master or a boundary clock functionality in the protection devices or via other methods suitable for event and fault logging. This separation not only improves resilience and cybersecurity, but also simplifies the management of the synchronization domains. The Postbus can operate independently while the station bus and control center maintain global time alignment for logging and diagnostic. So let's have a look how this looks in detail on the diagram what we have seen before. So at the starting, we have two Grandmaster clocks, so-called OCGC 1 and 2. And the OCGC 1 is the active master as per the best master clock algorithm. And the OCGC 2 is synchronized to the ordinary OCGC 1, means the Grandmaster 1. And that's why the MAC address of Grandmaster 1 is published within the SV streams. At the moment that the Grandmaster 1 fails and the Grandmaster 2 takes over without a jump because of the pre-synchronization, the MAC address in the SV streams changes to the MAC address of the Grandmaster 2 and is published within the S3 streams. So now the challenging part starts. The Grandmaster 1 returns back, but it will start first in a slave role, means it synchronizes him first back to the Grandmaster 2, which is the active master now, before it changes to the master role and returns to be the active master after that synchronization and achieving the required accuracy of 4 microseconds. And this, And this maintains now a time base a seamless time jump with a free running clock, and allows seamless protection operation without any blocking. So let's turn to a practical testing. The Omicron CMC test set can operate as a PTP Grandmaster clock. This is particularly useful when no suitable PTP master is available, such as in a lab environment or distributed testing scenarios with multiple CMC test sets. In this mode, the CMC acts as the master clock, providing a reliable time base for all connected devices. And you can also mix conventional inputs, means supplying current voltages hardwired to protection device and having alpha measures supplied with the measured waves and all is synchronized. An alternative is the CMC test set can function as a PTP slave clock, synchronized by an external grandmaster. This is ideal when protection devices operate as grandmaster clocks or when sample synchronization is managed over enterprise or substation PTP network. This is usually the most common mode you would operate such a CMC test set. Triggers are derived from the PTP time source, which is connected to the test set. Ethernet ports ensuring a precise synchronization during the testing and commissioning. If we talk about time synchronization, troubleshooting and monitoring is very important. And I like also to share my experience with the Daneo 400, a hybrid signal analyzer that becomes a valuable tool in our digital substation work. One of its outstanding features is its PTP capabilities, which is essential for ensuring accurate time synchronization across devices, especially when working with 6159-2 sampled values. From a user standpoint, the key functional benefits I see are the PTP sniffing and visualization. It gives you a clear view of the PTP traffic and synchronization status on the network. The verification of synchronization quality. You can quickly confirm whether devices are properly synchronized, which is critical for sampled values and goose reliability. The support of edition 2.1 is important. We learned that since this ensures compatibility with the latest standards, extended SV datasets, including the Grandmaster identity, and live monitoring and fault recording. It can run continuously and capture issues as they happen, which is great for long-term diagnostics. In terms of use cases, we have used the Daneo for commissioning and maintaining process bus systems, supervising substation networks over time, troubleshooting synchronization issues, which is where it really shines, validating merging units behaviors. From our experience at Siemens, the Daneo has been extremely helpful in troubleshooting synchronization problems in digital substations. One feature we heavily rely on is the event-triggered PCAP recording. So this allows us to capture both PTP and sampled value telegrams with precise hardware timestamps, which has been crucial for identifying root causes during complex time synchronization issues. That said, there are a few limitations. The number and type of Ethernet ports can be a bit restrictive, especially when trying to record in tap mode, which is important if you really want to see what PTP signals and sampled values are coming into a device and going out of a device. And another one is the number of ports are a bit less. So if you want to record on a LAN A and LAN B in a PTP setup, this requires two Daneo devices. Also, a lack of fiber optic ports can be a challenge in some environments. But still, despite these hardware constraints, the Daneo 400 has proven to be a reliable and insightful tool that's made a real difference in our substation diagnostic and commissioning workflows. So to conclude, avoiding jumps in the time base is essential for reliable protection and sample synchronization in digital substations. There are two main architectural solutions to mitigate these risks. First, the centralized PTP distribution approach by investing in hardened clocks, often equipped with atomic oscillators and distributing PTP centrally over the enterprise network, we can ensure stable and resilient time synchronization. This method is robust against GNS outages, jamming, and spoofing, but it does require significant infrastructure and investment. The second solution is the use of free-running Grandmaster clocks. This is a cost-effective solution that does not require the infrastructure or operational complexity of central PTP distribution. Free-running clocks operate independently, providing a stable relative time base for sample synchronization. This approach is immune to GNS-related disturbances and enhances cybersecurity by isolating the Prosbus network. However, it's important to ensure that protection devices can evaluate synchronization sources to avoid blocking during local synchronization states. An outlook to the standardization. Here, the upcoming revision of the IEC 62159-3 PTP profile is preparing the ground for the separation of time synchronization domains, which will simplify this distribution and management of multiple PTP domains in the future. Validation 2.0 is not yet released. These developments signal a move forward for more flexible and resilient architectures. What are the key takeaways? So both solutions with centralized PTP distribution and with free running clocks offer a viable path to mitigate time jumps. The choice depends on your operational requirements, budget, and desired level of resilience. By understanding the specific needs of each application and leveraging the right synchronization strategy, we can build a robust, future-proof digital substation. With that, I'm at the end. I say thanks for your attention and look forward to your questions.
Thank you,
so
Stefan.
much, Engineer Stefan, for this interesting session to close the day with. Now we open the floor for Q&A with Engineer Arul. Arul, the floor is yours.
With the time limit, I will take just one question. Stefan, thanks for the nice presentation. It covers about the time and sample synchronization along with the testing and monitoring solutions. There's a question from Eduardo Almeida. Why must a protection function be blocked when sample synchronization equal to 1, meaning local? What risk does this represent for power system protection?
That's a pretty good question. And the reason is usually you have redundant PTP clocks in the system. And if you have at least two clocks, you don't know which clock is really synchronizing my measured values, especially in transition states where you have a change between two local synchronized clocks. It can happen that for a couple of seconds, one merging unit is synchronized by one clock, while the other one is synchronized by the other clock. And this can lead to a misalignment of samples and consequently also to protection blocking. That's why you should analyze and evaluate the sync source ID to ensure that all of your samples are synchronized by the same source. And with the information of global, this is given since then the reference is global and you don't have to look at the sync source ID at all.
Okay, thank you, Stefan. And another question is, what's the difference between synchronization with sample sync equal 1 and the sample sync equal 2 in context of 62050? I think one of the slide you've shown this.
Yeah, the difference is really the reference. 2 is you have a global reference, means you have a satellite signal to which the time synchronization refers. Means you have a global reference. The signal is traceable up to a satellite signal. And with 1, the reference is a local clock. This could be either a free-running Grandmaster clock within a protection device or a normal PTP Grandmaster clock, which lost his satellite connection and starts drifting away. Since then it relies on its local oscillator, and that's why it's published in SampleSync 1, consequently on a merging unit, since the reference is not global anymore, it's a local source.
Yeah, thank you, that's correct. We got a lot of questions, but I will take one question as the last from Ibrahim Tahur. If the free-running Grandmaster clock maintains a stable relative time base, how do you ensure that the time on this network is correct and does not drift in relation to universal time?
So we don't care about that. Since here I said we use a specialization of synchronization. So we have two domains. One is used for the date and time synchronization, and this indeed has a satellite connection, but it's not used to synchronize the samples. So the samples are only purely synchronized by those free running clocks, and we don't need a date and time. And in the slides, you have also seen there's not even a date and time information within the sampled value telegrams. There's only a relative time reference to the clock synchronizing the sampled values. So this is completely independent and floating and free running. And for all of those applications using the date and time, like the records or PMUs, they of course need satellite-based synchronization, and this is separately done, either using a certain domain, PTP domain, or using SNTP, depending on the requirements you have on the substation.
Okay, thank you. And we have a question from Kale. I'm not sure which ID make that he's talking about, but I will just read the question for your information. I somehow experienced trying to remove the time sync from my clock, but my ID is still subscribing to sample value streams from my merging unit, which loses the time sync. Why does it behave like this?
Yeah, that's
I'm not sure.
a hard question without knowing the vendor, and if it's not a Siemens device, it might be even difficult for me to explain why this device behaves like it does. If it's a Siemens device, feel free to reach out to me and we can have a look on it, why this happens, what you observed.
Okay.
But I can't give an answer for that without those details.
Sure. Yeah. Thank you, Stefan. And in one of the slides where you've shown the flowchart, we have a question on the flowchart where the protection function blocked with the time synchronization and the protection function block with ANSI codes.
With one here, yeah?
Yeah, exactly. So here you talk about when the sample sync is not equal to 1, the protection functions are blocked, right? There are some protection function, time sensitive, for example, differential. But for the overcurrent protection function, do you mean here the merging unit is two different merging units coming to the protection ID for overcurrent? Like, for example, do you have any customer projects where you have CT inputs connected to a merging unit 1 and VT inputs connected to merging unit 2, and you publish two different streams to be able to protect the overcurrent function? Because there is a question about this topic. Why the overcurrent protection should be blocked when there is a sample sync on? Is it because of two different sources, or?
So yes, it depends.
Okay.
Usually you don't need to block overcurrent protection if you have just one stream to use on, or one measurement, since there's nothing to align. But if you have in a breaker and a half scheme, for example, two currents which you have to summate, we must be aligned. Otherwise, your sum will be not correct, and your protection would falsely operate. Either seeing a higher current or a smaller current, but definitely not the current he should operate on. So that's why I have written here also a block of protection using more than one measurand. So if you there's more than one measurand required, then this protection function should be blocked.
Okay, thank you. And it's the same applicable for distance as well, right?
Yes.
So if you have, okay, thank you. And that's it from the Q&A. Thank you, Stefan, for sharing your experience. It's a very interesting topic in digital substation projects.
Yeah, thanks. You're welcome. And if somebody from the audience has further questions, feel free to reach out to me and we can have a separate discussion on it.
Thank you, Stefan. And back to you, Marwa.
Thank you both. I now hand over to Mrs. Nadia Buslama from Omicron for the closing remarks.
Thank you, Marwa. Can you see me? Yes. Very good. Excellent, thank you. So, ladies and gentlemen, as we come to, ladies and gentlemen, as we come to the end of the 6PS Square System Protection Summit, I want to take a moment to thank each and every one of you. Over the past 2 days, we have heard valuable insights, exchanged knowledge, and explored practical solutions that matter to our industry. What makes PS Square so special is not only the expertise of our speakers, but also the engagement and commitment of this community, engineers, experts, and young professionals from across the MEA region and around the world. A sincere thank you goes to all our speakers, panelists, and contributors, and of course to our platinum sponsor, Omicron, and our supporters, whose continued commitment makes this summit possible. Thank you to the University of Bahrain for hosting the Young Engineer Integration Dialogue, and thank you to the organizing committee who worked tirelessly behind the scenes to deliver this experience, to deliver the 6PS Square. PS Square is the proof that even virtually, we can build connection, exchange solutions, and grow stronger together as a global community. I look forward to welcome you again for the 7th Power System Protection Summit next September with new topics, new discussions, and the same spirit of collaborations. Until then, thank you once again for being part of PS Square. Stay safe, stay connected, and see you next year.
Thank you, Nadia. And with that, ladies and gentlemen, we conclude the 6th Power System Protection Summit. Thank you for joining us over the past 2 days. Your engagement and questions made this event a success. We hope you found the summit both insightful and valuable. One highlight of this edition is the 1-year internship opportunity offered by Omicron, our platinum sponsor. Don't miss your chance to apply. The application link will be dropped in the chat and shared by email. As mentioned earlier, you'll receive an email next week with a recording of both days, so you can revisit any sessions. For those who attended at least 50% of the event, your certificate of attendance will be sent within 2 to 4 weeks by email. Participants from South Africa are eligible for SAE CPD points. The same applies for members of the Pakistan Engineering Council. Once accreditation is finalized, your certificate will be updated and shared via email. We remind you to submit your feedback via the polling tab before leaving. Thank you once again for joining us. We look forward to welcoming you back to next year's summit. Until then, have a wonderful day.